Good evening, sir.
Yeah, good evening, everyone. So I think let's wait for 2 more minutes and then we can start, right? In the meantime, I just need one help from someone. Can somebody share me the link of the course portal? Actually, I think something is wrong with my link. It was not opening. So can you
Okay,
just
sir,
paste
one
the link
minute.
in the chat box? Yeah, thanks. Yeah, thank you. Got it. So is the screen visible? Can you see the PPT?
Yes, sir.
Yeah, okay. Okay, then let's begin. I think we are around 15 people, so we can start then. Very good evening again, everyone. So we have come to week three now of this GenAI course, and I think by now you are quite accustomed to what neural networks are, right? What models do, what loss functions do, what activation functions do, forward prop, back prop. I think all those things are pretty clear now. And since this is towards the end of the week three, I'm sure you must have gone through the first live session as well as the lectures to get an idea of what week three talks about, right? So the main difference between what we do in week three and in the previous weeks is that in week one and two, what we did was we talked about simple numerical data, right? So we talked about simple numerical data, which we basically classified using neural networks, right? Classified or we performed some regression using neural networks. So what was the format of data? Like suppose you can have data like this, right? Where you can have height and weight pair, right? Where height can be something like 5.7, weight can be 50, height can be 6, weight can be 80, and so on, right? So simple numerical tables we had where we had different features and we had some label for classification or regression and so on, right? Now, what we'll do in week three and week four, we will talk about image data, images. Okay, so in week three and week four, we talk about data based on images. Okay, and what we try to do is using these images, we can learn something. Like we can classify the images into categories. Like suppose something is an apple image or something is a mango image. This can be some classification, right? We can also do classification and object recognition. Like for example, in the image, what object is there? Is it a human? Is it a dog? Is it a cat? Right. So all these different things which fall into a paradigm called as computer vision, basically that deals with processing of images. Now, what we did in the first 2 weeks was we also learned something that any neural network which is there can approximate and learn any function, right? If you make a new deep neural network with multiple hidden layers and multiple neurons, it can approximate and learn anything, right? So that goes for images as well. No matter how complicated the images are, if you design a neural network which is deep, if you design a neural network which is good, you can learn the images and you can also do analysis with the images. Okay, that is the main idea. Now, before we go into how the models are built and what type of models we have, we'll first try to understand what images are actually there. Like obviously, when you feed a image to a network, you're not going to feed the exact, like the network will not treat the image as the image, right? It will not see the apple inside the image. What it will see is it will see some numbers, right? So what we'll do first is we'll try to break down into what those numbers are and how the network sees the image, and then we will go into designing the model. Okay. So yeah, any questions or any doubts so far? Or shall we begin with the understanding of the images?
Yes, sir. We can.
Sir, will
Yeah,
you be
okay.
sharing these slides that you are teaching? Is it possible?
Yeah. So actually, from this week's content, you will get the slides of all the live sessions in the supplementary content, right? In 1 or 2 days, you will get that for the
Sir,
previous weeks also and for this week also.
okay.
Thank you,
Sir,
sir.
just a question.
Yeah.
Sir, I am only able to understand your session only. So can I get all your session videos? Like, have you explained all the contents of week one, two, three? Like,
Yeah, so every week I take the session on Saturday, so you can see the recordings on the calendar for every Saturday. Okay, you will get this. So
So
for every
yesterday, so recorded publicly also on YouTube.
can you tell me what is the channel for that? I actually don't have the access to the channel name, so I think can I stream 1 minute? Actually, I am getting a new ID. That is why I was not able to stream it last time with the student ID. But okay, so let me see if this will work. Just give me a minute. Let me check if the streaming will work on this. Okay, so in case it doesn't stream, we have the recording. So I'll download the recording and upload it on this channel. That I can do. Okay, so I think that will also work.
Yes.
Yeah?
Okay, sir.
Because
Yes, sir.
recording
Yes.
is happening. Okay, so it's already getting recorded. Just give me a minute. Let me just try if I can stream this right now. Otherwise, I will. Yeah, it's streaming actually on my channel. It is getting streamed. Like on my ID, it's not getting streamed. And don't worry, I'll upload it on the channel. Okay, I'll download it and upload it on the channel after the session.
Okay, sir.
Yeah. And otherwise, also you can access the recordings and the calendars. Okay, so you just click the calendar link. The recording will be available here. After, I think 1 hour after the session.
Okay.
Okay.
Every Saturday calendar date, right?
Yeah. Like last Saturday, if you go here, like on 4th October, I think we had the last session. So here you will see the recording is there.
Yeah.
Okay.
Okay, sir. Yeah. Thank you very much, sir.
Yeah, sure. YouTube, I'll just get my ID by next week, so I'll stream it on YouTube also. Yeah. Okay, so let's begin then with understanding images. Yeah. So basically, what you see in images are not obviously not the apples and the mangoes which are there. You won't see them as the computer or as a neural network. You see numbers, right? Because whenever we are training any model, we can only understand numbers. Our models cannot understand anything but numbers, right? So what actually images are? Images are actually of two types. One is called as a grayscale image and one is called as an RGB image. These are the only two types we'll be dealing with, and these are the only two types which are actually there. Mainly, rest are all combinations. Okay. So what is a grayscale image? The first thing is the grayscale image is an image which has no color. That's all. Okay. And the black and white, basically black and white images which you used to see earlier, those are grayscale images. Okay. Now, how does a computer see the grayscale image? A computer sees a grayscale image as a matrix. Okay. It sees a grayscale image as a matrix, a 2D matrix which just has two dimensions, height and width. So just like M cross N matrices you have, right? So a simple matrix, whatever the size of the matrix will be different for every image, obviously. But in the end, the image is converted into a matrix to the computer, and then the model sees this as a matrix. What are the values of these matrices? The values of these matrices are nothing but numbers between 0 to 255. So all these values which are there in these matrices, even this one and so on, all of them are just random numbers from 0 to 255. Can somebody tell me what are these numbers actually called? What is the other name?
Pixel values.
Correct. Pixels, right? So these are actually pixels. Okay, so for example, one image can look like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. This can be one image. Another image, maybe a small image, can just look like this: 1 pixel. Right? So it is just a different form of matrix that you will have to deal with. And these matrices basically will contain all pixel values ranging from 0 to 255. This can be different. Like this range is the standard range, and some images maybe now they have changed and they have expanded the range also, but there will be some fixed range of the values. Okay, you don't have to worry about that. Yeah, anyone raised the hand? So you can just directly unmute, okay? Because I'll not be able to see who raised the hand because I'm on the other
Yeah.
screen. Yeah.
Yeah. Yes, sir. I'm asking like these 0 to 255 are these RGB colors, because I feel like these are RGB. So
No, actually, these are intensity values. They are not RGB colors as such. They are intensity values. They give the intensity of an object. The higher the value, higher the intensity. For RGB, we also use a combination of this only. I'll just show you what RGB is. That is also a combination, but the number itself is not the RGB intensity. It is basically the object intensity, which the number is showing.
okay, sir.
Yeah, so you'll understand RGB also comes from this only. I'll just explain how this comes. A grayscale is fine, right? Everyone is clear with this simple 2D matrix, nothing else. Okay.
Yes, sir.
To RGB image. So what is RGB image? RGB image is a colored image. Okay. Now, one important thing, whenever we talk about colored images, colors are not just RGB, right? Red, green, blue are just three colors. We have infinite colors. We have yellow, orange, magenta, maroon, purple. So many colors are there, right? So why only RGB? Why not the others? That is because R, G, and B are standard image channels, and any other color which is there can be created as a combination from these three. Okay. So any color which is there can be created as a combination of R, G, and B. So that is why if we just have the red, green, and blue values for some image, we will be able to get the color of that image, no matter what color it is. Okay, that's the thing. So now tell me, if you have again RGB are also going to be pixel values. Let's assume that it's going to be pixel values from 0 to 255 only. So what do you think will be the difference between the matrix here and the matrix here? What is the main
It's a
difference?
three-dimensional matrix.
Correct, right? So
Yes,
why?
sir, it is a three channel.
Yes. So this is the whole image. One channel. This is the second channel, and this is the third channel. So again, you have m cross n matrices. This is m cross n. This is m cross n. This is m cross n. The dimensions are not different. They are again square matrices, but instead of having one square matrix which was here, so let's just call this m cross n only for no confusion. So instead of having one matrix, we are now having three matrices, right? And each of the values again will be intensity values of 0 to 255. Okay, and these three channels, as you see here, they are overlapped. So I can't draw the overlap, so I'll just get you an image. First, you have the feature map for the red. Feature map is just the matrix. Then you have the matrix for green, and then you have the matrix for blue. Then you just stack them up and you get the RGB image, right? How do you get the values? You can simply multiply this, this, and this to get the first value. You can multiply this, this, and this to get the second value. You can even add them up. So different images have different combinations of these values. We don't need to worry about that. We just need to understand that when we talk about grayscale image, we have a two-dimensional matrix, which is just m cross n. When we have an RGB image, we again have m cross n, but we have three m cross n matrices which are stacked. So this is a 3D structure, right? So grayscale is a 2D structure, RGB is a 3D structure, but all of them in the end contain different m cross n matrices. M and N obviously are different from image to image. The big image will have a bigger M and N, small image will have a small M and N, right? That is pretty simple. So is that clear so far? Any question on this?
Sir, how it's 3D image, like you have drawn three different matrices in RGB.
No, it's not a 3D image. It is a three-dimensional matrix. It has three dimensions, height, width, and length, right? Three dimensions.
Aviral, one after another, if you imagine, look at the picture in the screen.
Let me just picture on this label on this, maybe it will be clear. So you have this one channel, right, which is the width. You have the second one, which is the length, and this one, which is the height.
I got it. Yeah.
Okay, that's why the image. I'm not saying the image is 3D. The image can be a 2D simple image only, but the explanation, the matrices are stacked in a 3-dimensional. The matrix is 3D. Okay, that's that.
So you have drawn
have
three different matrices. So I thought 3D matrix, like how it's looking like.
Okay. So you got it wrong, right? This figure. Just remember this figure. Okay.
Yes.
Yeah. Any other question on this? This is very simple. So I hope this is clear to everyone. Okay. So in the session, as well as in the course and the exams and so on, we will be using combinations of grayscales and RGBs. It will be very simple. Whatever happens on grayscale, you have to do that 3 times for the RGB, right? So there is nothing special. So I'll be taking a combination of sometimes grayscale, sometimes RGB. You just need to understand. When I talk about grayscale, I'll just have one matrix. When I talk about RGB, I'll have 3 equal size matrices, right? One for R, one for G, and one for B.
Sir, I have one question.
Yes.
I'm not sure if you are going to cover this. If you are going to cover, then it's fine. But the question is how these numbers are determined. For example, whether it's a grayscale or it's RGB image for that matter, but the numbers are different at each cell value, right? For example, in diagonal or so how that is determined? Is there, or are those always the random numbers?
No, they're not random numbers, like exact determination process. So I also don't know. You'll have to ask an image engineer. But how they determine, the idea is these are intensity values. So if the thing is more intense, the number will be higher. If the thing is less intense, the number will be smaller. Like for example, you have an image which contains a tree, and in the very big background, you have a small bird, which you can't even identify what bird it is. So for the bird, the pixel values are going to be smaller. For the tree, the pixel values are going to be larger. That is the thing, right? Exact value how to determine that I also don't know.
May I try to give him a sense?
Yeah, sure.
Yeah, if you take 3 colors, maybe for get a better idea, you take go and take 3 paints, red, green, and blue, and try to intensity means how much you are adding.
Yes, correct.
You add a drop of red, 2 drops of green, 3 drops of blue, and then mix it. You will get a color.
Yes,
then
correct.
You make different combinations, 3 drops of red and like this. This is what is the intensity. The same thing what you are doing with the paint, here every pixel will be having similar intensity.
Yes.
1 drop means 1,
Yes.
So assume 255 means 255 drops.
Yeah, the most intense, right? The most tense thing. So you can even
Like
call
this, you
intensity as
can.
density, something like that. You can visualize. That is easier to visualize, right? So you can, like, another example which I can give you is, suppose you are shading this blue. If my blue shade is very light like this, then obviously my intensity is less, right? So my pixel value should be smaller for this. But on the other hand, if I am making this blue shade, this is very dark, right? So my intensity is quite high. So my pixel value should also be high for this. So this is not a concrete explanation, but this is just an approximation. What was trying to be said, right? So visualize it like this. Yeah. So is that okay?
Okay, sir.
Yes,
Thank you.
sir.
Thanks, Karthik.
Yeah. Okay. So don't worry, we'll not ask you a question on how to find the value. That will be given to you. But yeah, that was a good question indeed. Okay. So I think that is the main idea of image data, how the data is going to look like. Now there are two more things that the images are, some of the images will have. Like not all images will have this, but some images will have, and definitely the images you get in the question most probably will have these things. So let's look at these two also. The first thing is called a padding. Why it is done, we will understand after 10 minutes, because when I explain the model, then you will understand why padding is important, right? But let's just try to understand what padding means. So padding is simple, just like you have an image, like this is a 3x3 grayscale image, right? Where you can see all the different pixel values are given. When you have to make the size of the image large, okay, just the size of the image to the computer has to become large, you add padding to it. Okay, and how is padding added? Suppose you say padding is equal to 1. That means I'm going to add one padding. So what is one padding? Padding is always done with zeros, okay? The value is always 0 because you don't want to create a new thing in the pixel, right? If you create some 5 or 7 as a value, then something will get created. I don't want to add something, right? I just want to increase the size. Okay, so padding of 1 does not mean you just give 1 0. Padding of 1 means you give 1 0 everywhere. Okay, so 1 0 on the top, 1 0 on the left, 1 0 on the bottom, and 1 0 on the right. Okay, this means padding of 1. I have added one layer of padding. Now, can you tell me what is padding of 2 then? What will happen if I write padding is equal to 2?
There'll be 2 layers.
Yes, so just make
Zeros.
another 0 here, right? Okay, so whenever I'm doing padding, I'll just be given this in the question. Suppose if you get a question, you can see the GAs and all for this. If you see the GAs, you will see I've given in the question padding is 1. So what does padding mean? Padding of 1 means I have one layer of 0. So one layer of 0 is on the top, on the bottom, on the right, and on the left. Okay, so one full layer of zeros, top, right, bottom, left. Similarly, if I say padding is 2, two full layers of zeros on top, right, bottom, left, everywhere, right? And another thing important is the value which is used for padding is always 0. Okay, why is it 0? Because 0 means nothing, right? So there will be no pixel value or no intensity there. So if I want nothing to happen to my image, only the size to be increased with the help of the pad, I will give the padding with value 0. If I give it with any other value, then there will be something, right? So if I give it with 255 or maybe 241, some pixel intensity is getting created. Something new is happening in the image. I don't want that. I just want this mathematical size to be increased. That's all. Okay. Right. So I
So
have
padding will always be 0, or can we have other?
See, you can
padding?
write, see, all this is done by code, so you can modify a code and pad it with 5 also, but then something will happen to the image, right? You're altering the values also. In that case, you're creating something. I don't want anything new in the image. I just want the size to be increased. That's all. Okay, so that's why I'll pad it with 0. So then nothing happens to my image. Like this image becomes this image. But if this image had only a dot here, I don't want the padding to be this and 2 dots. I don't want something new to get created. I want the padding to happen, but the dot will be 1 only. There will be nothing new created. That's the idea. Okay. So this I don't want.
Will the quality of the image will decrease like on padding?
No, only the size will increase. Nothing will happen to quality.
That is
Quality
zooming the picture actually.
Is it like SVG where we zoom infinitely but the quality
we're not
doesn't increase?
zooming, like exactly we are not zooming, but yeah, you can think of we are increasing this, yeah, kind of a zoom, but the object won't become larger because you're just increasing the size. You're not focusing on a particular object to make it larger, like in zooming. So you're just expanding the size. Like actually, the best idea to visualize it, if you click a photo and you click a passport size photo of yourself, and on the other hand, you click a A4 size photo of yourself. So you're not exactly zooming too much. You're just increasing the size of the image, right? Your face will still look the same only. It won't be a zoomed face.
Yeah,
right?
Means we are increasing the frame size actually. Na?
Frame size, exactly.
Okay.
So this is the image. Now I'm making it this. The object was this. Object is still this. Okay, that's the idea. I'm increasing the frame size. So A4, A3, you see the papers, right? A4 size paper, A3 size paper. So that is what I'm doing. I'm just increasing the size.
So image size will be same.
No, image size is going to be increased, right? The image will be same, but the size of the image is increasing. This was my initial image. Now this is my final image. So this is bigger,
Okay, so
right, than the previous one.
yeah. So my question was like, if it's JPG image, let's suppose, then if I try to increase its size, then its quality will decrease. But it's SVG, then its quality will not decrease. So like that's how I was asking. Like,
Okay, I'm not very sure about that, but I think in padding we don't affect the quality. So it might be SVG format that we are using. I'm not sure about that, but we don't
okay,
change the quality. Okay,
Yes.
quality does not decline.
okay,
Okay, yeah. Okay, one more just a question to everyone. Let's assume that the dimension of the original image was m cross n, right? It's of course 3 cross, you can see it is m cross n, and I have added padding is equal to 2. Can you tell me what is the dimension of the new image?
M plus 2 times
Yes,
n plus
correct.
2.
So I'm basically adding 2 on everything, like 2 more rows and 2 more columns. So this is going to be m plus 2, n plus 2. Is this correct?
Yes.
yes,
Yes, sir.
Yeah, correct. Are you sure it is correct? Because I don't think this is correct.
sir. It should be 4.
M plus 4.
Exactly.
It
Because
should be
see,
4 actually.
m plus 4
Before.
and n plus 4.
Yes, sir,
Exactly.
right.
This is
Yes.
correct. Because you're doing it on bottom also and top also, right? And your left
Yes,
also
sir,
and right
both
also.
side include.
Yeah.
Both sides. Like you just see this one. This is 3 cross 3 and I've done padding is 1. It is 5 cross 5. Right? So 3 plus 2 and 3 plus 2. Right? So think of it, it's happening on all the sides. So this is something you have to remember. Okay? So yeah, I think that's clear, right? The padding part. Any question on this?
Sir, in yesterday's class, we saw that actually we were first putting some sort of kernel or filter on the input,
Yeah.
and then after that we were doing padding, not like this, like entire and on the entire
No, we are
image.
not talking about kernel right now. We
So,
are just talking about the image. Kernel is in the model. We have not come to the model yet.
okay, sir.
Okay.
So padding can be done on image as well.
Yeah. That is not padding is done on image only before applying a kernel. After applying kernel, the padding will be used by the kernel, but nothing will
Okay.
happen to the image. The padding has to be done first before applying the kernel. Okay. So let's come to the kernel. You'll understand why. Padding is not before kernel. It's always after kernel. Sorry, padding is never after kernel. It's always before kernel. First you do padding. Okay. So we'll come to kernel. So don't wait for 5 minutes. We'll just come to kernel in a while. Okay. Yeah. Any other question on padding? Is it fine? Clear?
Sir,
Yes, sir.
padding is used for prevent shrinking, right?
Yeah. That's why I told you. I'll tell the use in a few minutes time, because the use of padding, you'll understand when we talk about kernels and the convolutions. Then we'll understand why it's used. Okay. Yes. Right now, I'm just trying to explain what padding is doing. So that is clear, right? How we pad and what does it do?
Yes,
That
sir,
is the main thing. Yeah.
crystal
Okay.
clear.
Okay. So now I think we can start with the model. The main thing I wanted to explain was this channels, right? How the image data looks, and the second thing was this padding. All right. So now that we have understood the data, now let's come to the models which we will use to understand these images. Okay, so the model that we will use to understand images is again a neural network, but instead of having a neural network like this, which we were dealing with, which is also called as the MLP, right? The multi-layered perceptron, we don't use these for the images. Again, I'll come to that why not. We can even use these, but there is a reason why we don't do that we will understand in a while. The special category of models that we use for understanding images are called as convolutional neural networks. Okay, that is the category of models, and in short form, we also call them as CNN. So this architecture of models is called as CNN, which is convolutional neural network. Now, what is happening in the CNN? This is the whole CNN which you can see. What we'll do is we are going to be basically breaking this down into different components, and we'll understand how each component works. And then in the end, we'll again come back to the figure to make sure that we are clear with it. Let's just try to get an overview of what it does. Firstly, of course, we have an input, which is an image, right? So let's assume that the task that we are trying to do is image classification. Okay, this is the first task that you work with on images. So obviously that means I'm going to give an image and I want the output to be whether it's an apple or whether it's a mango, right? So I'm basically classifying the image into apple and mango. So obviously the input data that I give is going to be an image. Can you tell me if this is an RGB image or a grayscale image? What is
It's
this?
a grayscale image because the channel is 1.
Grayscale.
Basically, don't get confused with the three numbers. This is just 28 cross 28, right? Because channel is 1. So this is a grayscale image. So I've given a grayscale image of course, this is a number 2. So it's a digit classification I'm doing. So I've given a grayscale image here. I have passed it through the entire network here with all different components, which we will see in a while. And in the end, what I've got is I have got these output probabilities, right? Which I was getting in the MLP. So for example, it says apple is 0.75 and mango says 0.25. So obviously I know that this image is an apple, right? Can you tell me in the entire architecture here, what all is looking similar to the architectures we saw earlier in the normal neural network? Is there something looking similar among all this?
Yeah, the last part.
Yeah, so this is same, right? This is a normal neural network, which you see in the end. Can I also
Yes.
say that at the end a softmax is sitting, a softmax function for doing the
Yes.
probabilities?
Yes.
That is
If it's
also true, right?
multi-class, then we should use.
Yes,
the
so these are all the classes, and all these classes will actually be probabilities, right? So I have a softmax function also, which is sitting. And of course, I have an input. In the normal neural network also, I used to give an input. So here also, I'm giving the input. So three things that we see. So let me create a new slide. Let's see what all is same and what all is different. So when we talk about CNN, the first thing that we saw was the input. Of course, the input is an image now, but there is still an input, right? I'm passing. So this is same, which was there in the normal MLP also. Then if you see the softmax at the output, this is also same because I'm doing probability classification, so I have a softmax. And finally, if you see, you have the final layer MLP, which is also right here. In the end, we have an MLP. What is different is these things. This first type of layer, which is here, this second small type of layer, which is here, and then this. Okay, these two are similar to these two, and then this flattening. These three are different. So what are these three called? The third one is called as convolution layer. That's why the name CNN. Fourth one is the small layer, which is called as the pooling layer. This is the fourth one. Fifth one is pretty simple, and this is called as flattened layer. Okay, this is the most simple one is this. This will come to in the end, but this is also a very simple layer called the flattened layer. So with the combination of these things, input, softmax, MLP, convolution, pooling, and flattening, with the combination of all these six things, we build a CNN. That's the idea. Okay. Among these six things, these three things we already know, so we are not going to work with them much more because we already know them. Okay, so we'll see them in action later on. These are the three things that we are going to focus on. This one, and this one. So can I start with these three now? Is the idea clear how a CNN looks like?
Yes, sir.
Yes, sir.
Yeah. Okay. So let's come to convolution. So if you see, convolution is right after the input, right? I give an input and the input goes into the first convolution layer. So this is the first convolution. So let's see how convolution works. So what is happening? Let's assume this is the image that we are dealing with. 1, 2, 3, 4, 0, 0, 5, 1, 0. This is the image. Okay, so it's a simple grayscale image, 3 cross 3, which is my input. So this is my input. I can also call it as X, right? Because we know input is written by X. Now what happens in convolution layer is, in convolution layer, we use something called as a filter or a kernel. It is also called as kernel. Now this kernel is the most important thing. This is what determines how your image classification is going to go. What is this kernel? This kernel is also a matrix. First of all, the first important thing is this kernel is also a matrix. Dimensions we can decide, right? So we can decide what the dimensions is. It can be a 1 cross 1, 2 cross 2, 3 cross 3, and so on, whatever we want to do, right? What does this kernel do? This kernel performs an operation on this image called as a convolution operation. Okay, and after this convolution operation, we get another matrix which is called as the output of that layer. Simple thing, I'm passing an input, I pass it through a kernel which does a convolution operation and gives me back another new matrix and the output. That's a simple idea. Okay, now let's try to understand what the kernel is. The kernel I told you is a matrix, right? This kernel is a matrix. So what will be there in the matrix? Can someone tell me what will be there in the values of this matrix? Let's assume it's a 2 cross 2 kernel. What do you think is going to be the values of the 2 cross 2 kernel? Something fixed?
Pixel values.
Or 0 minus 1.
No, that is actually both the answers are partially correct. The idea is kernel can have any value. Okay, kernel can have any value. So you don't actually fix anything. What you actually do is you make the kernel learn. So if I talk about learning in a neural network, what comes to your mind? What do we learn in a network? Weights, right? Using backpropagation and those things. We learn weights. So basically what my conclusion was, in a CNN, the kernel is the weight. So basically in the normal network, these weights you're learning, right? This and this. In CNN, you learn this. These are the weights. This first one, second one, third one, and fourth one. If a kernel is 2 cross 2, you learn 4 weights. Okay. So when the CNN learns, what we actually learn is the kernel. What is the good kernel for that image? Okay. We don't specify that this kernel is good or this kernel is good or that kernel is good and so on. We learn the kernel using a forward prop, back prop, gradient descent, and all those algorithms that we talked about earlier. Using a combination of that, we make the filter learn. Right. So for example, at the beginning of this CNN, my filter might be this. right? And after 5 epochs, let's say 5 epochs of learning has happened, my final filter is this. So this is my final kernel. Okay, the network has learned and it has learned, and whenever I have a loss function, this kernel is minimizing the loss function. So this is the best kernel. Okay, this is the main point. So the kernel is not fixed. The kernel is actually the weight of the network, and the kernel is actually what we learn in the network. Okay, is that point clear? Any question on this? Yeah. Okay. Okay, now let's see how the kernel actually.
Excuse me, sir.
Yeah.
So it means, yes, kernel here is analogous to the weight which we studied in
Yes.
the, yes. So it means for the very first time when an image is fed into this model, the weight should be assumed at least.
Yeah. There will be some
The
initialization.
first kernel will be an assumed kernel.
Yes. First is initialized. Correct.
Okay.
Just like in a ANN, we initialize the weights first, right? It's the same
Yes.
thing. First kernel is initialized. So by any random values we can give. So generally we give combination of zeros and ones to initialize, and then we learn the exact values. Okay. Yeah, I think someone raised the hand. So yeah, go ahead.
Sir, in some of the classes, we saw that for edges and for different kind of learning, the kernels are like they are combination of zeros and ones and minus ones
correct.
and all of that.
Correct.
So are those learned kernels? Or
Yeah. They have
are
been learned and
initialized
experimented
kernels?
on. Yes, they are learned kernels. Yes. They were learned about different CNNs, and then the experimentation have shown that these values do well. So sometimes we use those fixed kernels also, but they are already learned. Okay, so when you use a pre-trained model, those kernels are learned. Okay.
So,
But
sir,
whenever we build our own CNN, we'll have to learn a kernel. We cannot fix any kernel in the beginning. We have to learn it.
So it's very strange that these learned kernels are coming so nice actually.
Yeah. They are very symmetric and they are very beautiful kernels. That is true. They have very good values, like ones and zeros, minus ones, combinations of those, right? So yeah. They do. Yeah.
Okay, sir.
Okay, so now that we have understood that kernel has to be learned, so let's assume that the kernel has been learned now, and let's see how a kernel actually performs an operation on this. I told you, right? You have an input, that the kernel performs an operation and you get an output. So let's try to understand what this input-output combination is. So let's again start with our simple image. So we had this 1, 2, 3, 0, 0, 1, 0, 1, 5. This is the input image that we have. And we will pass this input image into a kernel. So let's assume the kernel is a very simple kernel, 1, 1, 1, 1. This is the first kernel, right? So this is the input. This is the kernel, and this is the output. So how is the output actually formed? What you do is, you basically, the term is called as stride. You stride the kernel on the image. So what does striding mean? Initially, this kernel you see is 2 cross 2, right? So what I'll do to begin with is, I will stride or just keep this kernel on this window, right? And once I keep this kernel on this window, I'll simply do a dot product. So can someone tell me what the dot product is going to be between the kernel and this?
3.
Sir, element wise.
So 1 into 1,
3.
2 into 1, then 0 and 0, right? This is 3. Then what I'll do is, now the stride is again something I'll come to. So let's assume the stride is just 1. So I'll just go 1 by 1. I'll just shift the kernel with 1 block, right? So on my next iteration, I have shifted the kernel again. And now my kernel sits here. So what is the output now? Can someone tell me the output? 6, right? So 2 into 3 plus 1. Yeah. So is it 6 or 7? Yeah, 6. Okay. Then what I do is, I again shift the kernel by 1. So this kernel now goes here. Can you tell me whether there will be something here or not? Should I stop here or should I compute something here?
Sir, we can do the padding.
So
No,
padding.
we can use padding. There is no padding here.
Padding.
There is no padding. So what will I do? If there is no padding, should I stop
So
here?
go to bottom.
Stop.
Then
Sir,
next
slide.
yeah, bottom.
Yeah, correct. So we'll go to bottom, but we'll stop here. We'll not do anything here anymore, right? So if there is no value, there is no operation. So this horizontal kernel is over. Now what we'll do is, after this horizontal thing is done, we will take the kernel vertically. So vertically, my kernel was here. I'll shift it by 1. So my kernel goes here, right? So now what is the output here? 1, right? Rest all is 0. Yes.
1.
Then what I'll do is, I'll see again that can I shift horizontally now? So I can shift, right? Because I again have a 2 cross 2 here. I can shift horizontally. So I shift my kernel here. And what's the output? 7.
7.
Yeah. Can I shift in the horizontal direction now? Is this possible? I can't, right? Again, I'm finished. Can I do vertical direction? Is this possible? No, right? Because now I'm again finished. So once nothing is possible, you stop. That's it. So this is my output. Okay. So with stride is equal to 1, what I did was, I first shifted the kernel horizontally by 1. Once I was over, I again shifted it vertically by 1. And once I was over there, I stopped. right? And in the end, after applying these dot products, I got this output. This output is also called as a feature map. So that is the term you will see in the questions as well. This output is also called as feature map. Why it's called as feature map? Because this output has learned something from the image, right? So I had something in the image, this kernel was used, and something from this image has been learned by the network. That's why it's called a feature map. So is the convolution operation clear to you? How does the kernel actually stride over the image and perform a convolution? Is the idea clear? Any question on this?
No, sir. Thank you.
Yeah. Okay. So this was with stride is equal
But
to.
the kernel was given, or we have to assume.
This was the first kernel. This will be initialized randomly. Then with this kernel, if this feature map is not good, like if the loss function is high, then we'll again backpropagate and we'll change the kernel. So for the first iteration, you will have the kernel given to you in the question. You don't have to learn it.
Sir, you
Okay.
can assign randomly first kernel.
Yeah, randomly. This is random. Okay.
Oh.
And is this just coincidence here, or the size of the output will be same as the size of the kernel?
No, we'll come to that. It's not a coincidence. There is a fixed formula for that. We'll come. That is the main formula of your CNNs. We'll come to that. So this one. Okay, we'll just come to it in a minute. Okay, you can determine the size of the output. Okay. Yeah, this is not a coincidence. For this particular case, you got the same thing. Okay, so this was with stride is equal to 1. Now let's do the same thing. Let's change the stride value. Stride is shift, right? So you can think of it like shifting the kernel. That's called a stride. So again, we have this kernel. This was 1, right? Here. Now we have stride is equal to 2. Kernel is still the same. I just have this one. So can you tell me what the output is now in this case? First is same, right? No change here. So I'll have the same element, 3. Where will I shift now?
Right side.
Bottom.
Bottom.
Okay, first let's do the right shift. If we shift by 2 to the right, we have this, right? Not possible. I can't do anything here. Let's shift by 2 to the bottom.
Yeah.
Three bottom not possible.
Bottom is also not possible, right? Because it's over in both the cases. I have to shift by
Yes,
2.
because two step move down.
Yeah, so I can't do anything after 2 steps, right? Because once I move down 2 steps, it's over. I have nothing here, right? That means this is my output. My convolution is over. This is my new output. Okay, so I got a 1 cross 1 output. Okay, that's it. There's nothing wrong in this. This is how it works. So the way you determine the kernel size, the way you determine the image size, the way you give the padding and everything, that actually determines your output size. Okay, let's try one more case. Yeah, I'll just come into the question. Just a second. Just speak directly. You don't need to raise the hand. You can speak directly, okay? Because I'll not be able to see the hand. Yeah, Chandra Prakash, yes.
So there were 4 possible answers in stride equal to 2. So
How are
it
there
will-
4 possible answers? Can you tell me? Yes.
Sir, because I mean, depending on where you start, right?
You have to always start here. You can't start from here. Starting has to be on the first value. Like if this is the image, you have to start from here. You can't start from here or here. That is fixed. Okay.
Sir, but ultimately we are trying to learn features from that image, right? So,
Yeah, that is true, but that is how the network is actually designed. You cannot start arbitrarily. You have to start from the point that is given, the first point. Because if you start arbitrarily, every CNN formula or every CNN result that is given, all of them will become false in that case. The starting point has to be from the top. Like if this is the image, you have to start from here on the top. You cannot start from here. That is not allowed. Okay, so this is fixed.
But sir, in this case, we are losing data, right?
No, we are not losing any data. Like what type of data are you talking about?
Because
The values.
Yes.
No, we are not. See, we are not losing. See, the idea is, suppose this is an image of a tree. Here, you have an image of a tree and the sun here, and you are putting a kernel. The kernel will learn something from it. So, suppose this kernel learns the tree. Okay, or let's see, there is another kernel. That kernel just learns the branch. So, I'm learning something. I'm not losing data. I'm not going to do one kernel. Like I can do multiple kernels also. One kernel has learned this tree. One kernel has learned the sun. Let's have another kernel. That kernel learns the sun. So I'm learning something from each of them. I'm not losing any data. I'm extracting some information.
So the pixels in the border are not. Kernel doesn't see those pixels.
They can see, right? If you do a padding, then they will be able to see. In that case, right?
Yes.
So I was taking that as an next example. So let's basically do one more thing now. Let's take padding and let's see how it works, right? So let's have the same image now. So this is 1, 2, 3, 0, 0, 1 and 0, 1, 5. Now what I'll do is I will add one layer of padding into this image. So let me draw it a little neater. So just a minute. Yeah, so what I'm going to do is now I'm adding a padding layer to this image. So that means I'll add a 0 here, I will add a 0 here, and I will
So
add...
in this case, model will decide whether the padding will be added or not.
No, we will decide. We will give that. In the architecture, we will give that, whether padding has to be added or not. Model will not decide. So all the padding, stride, kernel size, initial values, everything you will have to decide when you build your code. Okay?
But so
Yes,
these are
before-
hyperparameters, right?
Yes, they are hyperparameters. All of them are hyperparameters. Like
We
in the
don't-
normal functions, we had the relu, gelu, we had the choice of the activation function as one hyperparameter, right? How many hidden layers you'll have, that is a hyperparameter. In the CNN, all these are hyperparameters. Padding, stride, kernel size, kernel initial values, image size, all this is controlled by you. Okay?
Right, sir.
Yeah, so I think this is a slightly untidy drawing. So let's me just go back here itself and I'll just copy this part, okay, for the drawing, because this will be a little clearer than how the padding is happening. So yeah, so okay, so now I've applied padding into an image, okay, and I'm going to stride my kernel on this now. So again, I have a same 3x3 image, but I've padded it. Okay, my kernel is again this 1, 1, 1, 1. So can you tell me what will be the output now in this case? Same kernel with the padding now. So let's start from here. So we'll have stride is equal to
0.
stride is 2, okay? So this is 0. Okay, now where will it go after this? One
It will
second.
move to the completely blue part.
Yes, because I have taken stride of 2, right? So
2.
first it went here. Now it jumps
Then-
by 2 and it goes here. So I have
Yes.
one more output here, right? So what is the output now? The output
3.
is 3.
3.
Okay, can it jump anymore?
No.
It
Move
can't, right?
bottom.
If it goes here. So there is no jumping. Okay, let's go to the bottom now. Let me start from here then, right? This is my next part. From the bottom.
No, sir. Stride is true. Two. So
Yeah, I've done 2, right? I have done stride is equal to 2.
9. 9. This way.
9,
It's
right?
in
Yeah,
9
3 and
now.
6, 9. So I'll take this part. Sorry, I'll take this part, and my learning is going to be 9. Okay, now let's go again here. I'll go here, and the learning is going to be 11 and 5, 24.
26.
20.
stride is 2. So
Yeah,
we
stride is
should-
2.
24.
Okay, yes.
24.
Stride is 2 means I was here. I jump 1, I jump 2. I come here, right?
Yes, sir. Yes, sir.
Yeah, stride is 2. Okay. Now with the same image, if I would have taken stride is equal to 1, then again I would have got something bigger, right? Because then I would have had more elements.
Yes.
Yes, sir.
So I had something bigger. So basically what I'm trying to prove by this is the convolution operation with the same filter and the same image can have different outputs depending on the stride value and the padding value. Am I right?
Yes, sir.
Right.
Absolutely
Yes, yes.
right.
Correct, right? Yeah. So with this motivation, we can come to this formula, which is going to be very, very important for you. And this is something you need to remember. This is also called as a CNN formula. Okay, this is the main result of CNN. So what you do here is, if you are given the stride value, if you are given the padding value, if you are given this F means the input, right? This is the input image size, and K means the filter size. If you have these 4 hyperparameter values, you can predict what the output dimension is going to be. Right? So let's try to apply this formula into the situations we were talking about. So suppose I have a 3x3 image, right? This is the input. This is the input image size. I have a 2x2 filter. I have padding is equal to 0 and I have stride is equal to 1. Can you tell me what is the output size in this situation?
2 cross 2.
Yeah, so let's fill it in the input. So this 3 minus filter size is 2 plus 2p is 0, right? So I have no padding. This is 0 divided by 1 plus 1. So this is 3 minus 2, 1 plus 1, which is 2 cross 2. Right? So if you have a 3 cross 3 image, so if
Square
you see,
matrix, no? Always.
yeah, square matrix, yes, square, always square. Okay?
So
Always
in case of rectangular matrices,
In case of rectangular, apply it on length and breadth separately, if it's rectangular. Okay, but we won't give you any.
If the fraction it's come in the fraction.
Yeah, very good question. If it's a fraction, like suppose it's 1.5, then you take the floor. That means it's going to be 1.
Oh.
Okay? So take floor. This is very important. Also, I think there's a question on GA based on this also. Take floor in fractions. Okay, always take floor. So if you have a decimal, just round it to the lower number, not the upper number.
What is the meaning of decimal here?
No, suppose this mathematics gives you a fraction in the result. It can give you a fraction also, because suppose the stride was 2 in this case, I'll get a fraction, right? So I'll round it off to the lower number in case of a fraction.
We're talking about O con.
Ocon, yes, the ocon, this ocon, if it's a fraction, I'll round it off to the lower number. I'll take a lower dimension in that case. Okay, but you won't get many cases of this, so don't worry about this. Just like if suppose I ask you a mathematical question in the quiz and you get a fraction, round it to the lower number. That's all. Okay, in general, whenever we do designing, we never get fractions because we make values in such a way that the fraction will never come. We'll always get a fixed value. Okay, this is just for the math part. Okay, let's now see if this is correct. So we see what we were doing is we had a 3x3 input, we had a 2x2 filter, we had no padding and we had one stride and the output was 2x2. So let's verify it. So if you see, this is correct, right? This was our first case. No padding, stride is 1, input is 3x3, kernel is 2x2 and the output is also 2x2, right?
Yes.
Verified? Yeah, let's assume for this one now, the second case where basically we have the same thing, but we have stride is equal to, let's insert a slide here. So again, we have input 3x3. We have
a fractional value.
Yeah, just a minute. So we have out the kernel is 2x2 and stride is 2. Yeah, so we have a fraction, right? Because this is 3 minus 2 plus 0 divided by 2 plus 1. So what is this? 1 by 2 plus 1, which is 0.5 plus 1, which is 1.5, right? Then take a floor. If you take a floor, you get 1. Correct? And that's what we had. If you see, we just have 1. Got it?
Yes, sir.
Okay, let's take it for the last case also. Now, in this case, we had padding, right? So let's do it here itself to save space. So can you tell me how the calculation will go for this one? 3x3. Sorry, the image is 3x3. Kernel is 2x2. Stride is equal to how much we took? 2, right? Yeah, 2. And padding is equal to 1. Okay, let's calculate now. So it's going to be 3.
Feature map will be 2 by 2.
2x2, right? So 3 minus 2 plus 2 because 2 padding, right? Plus 1 and divided by 2. So what is this? 1 plus 2, 3 by 2 plus 1, which is 1.5 plus 1, 2.5. Again, take the floor, you get 2. Right? Got it?
Yeah. Yes, sir.
So I think now if we are given the input size, the filter size and the stride and padding, I think now all of us, we can calculate what the output is going to be, right? We can actually calculate the output also, and we can also predict what the output dimension is even without multiplying. Right? So any question on this? This was the most important formula. This you have to remember. Please learn it well.
Can you give us a rectangular image and a rectangular kernel? Then it will be interesting.
Okay, let's try that as well. So I want one of you to try it out first and tell me if it's working. So let's take this image 1, 2, 3, 4, 5, 6, and let's take this as the kernel. Okay, try this out. Stride is 1, padding is 0.
So the formula is same, but
Sir, could you please repeat the question?
Question is, this is the new image, this is the new kernel. Okay, this is the input, this is the kernel. Stride is 1, padding is 0. Calculate the output dimension using this. So basically one thing here, the output dimension is not going to be square, right? So you have to calculate the length separately and the breadth separately. Exactly. So let's do it for the length first. Yeah. So can someone tell me what will be the values for the length? What is the input length? 3, right?
Yeah, 3 cross 2. Yeah. So 3, let's start with 3 minus 2.
2 plus 0, no padding. Okay. Right. Divide by stride, which is 1 plus 1. Yeah. So this is 1 plus 1, 2. Right. So length is 2.
Yep.
Now let's do the width.
2 minus 2. Sorry, 2 minus 1.
Minus 1.
1.
2 minus 1.
1
plus 0.
Divide by 1.
1
plus
plus 1.
So this is 1 plus 1, which is 2. So we get 2 cross 2.
Yep.
Let's see now. Can we get 2 cross 2? So
yes, sir. We get 2 cross 2. 7, 8, 13, 16.
Yes. This is 1. This is 1. Then you stride this like this and this. You get 2 cross 2. Right? So whenever you have a rectangular image or a rectangular kernel, you do it separately for length and width. When you have square image and square kernel, then whatever is the length is going to be the width, right? So you just apply the formula once and get it done with.
Sir.
Okay. Yeah.
Sir,
yeah, you're selecting
we can.
Hello. You're selecting 2 elements, so it's based on the kernel size, right?
Yes. Because the kernel has 2 elements, right? That's why I'm selecting. I'll multiply 2 with 2, right? That's why.
Yeah. Okay, sir.
Yeah, Disha, something you were saying? Disha, you were saying something. I think you were saying, right?
Yes, sir.
Yeah.
Sir, could you please explain width again?
See, width is what is happening here was earlier we were having square image, right? So height and width, this is all 3 cross 3, right? So height and width was same. So now in this new image, you can see the height is what? The rows, right? Which is 3, but the width is 2. We have only 2 columns. Here also the height is 2 and the width is 1. So because the values are different now, we first apply the formula on the heights, which is this, and then we apply the formula on the width, which is this. Okay, so because the values are different, you first apply it on the height and then you apply it on the width and you do it 2 times instead of once. Got it?
Okay, sir.
Yeah. Why we were doing it? Because the height and width are different here, right? If they were same, then I can just apply the formula once and I'll get the same answer for both, right? Which I was doing in the earlier cases. Now because it's different, I'll apply the formula twice and get the answer. Okay?
Yes, sir.
Yeah, okay. Okay, so this was mainly about the convolution layer. So now if you have any question on convolutions, we can take that up. Then we will move on to the next part. Yeah.
So so if my image size is m cross n.
Yes.
And kernel is, let's say, p cross q. Just
So
to
1 minute, I'll just write it only somewhere.
Yeah, so then it's like solves all the problem. M cross n.
And kernel sizes?
Let's say p cross q.
Okay.
And
Stride
then,
stride
is s.
Stride is s and padding is p.
P, yes. So then that's it. Once we understand it, then it's all
Yes.
solved. Yeah.
So what will happen to the height? The height will be m minus p plus 2, we'll call it capital P for padding, okay? 2p divided by stride plus 1. This is my height, okay? And what is my width?
n minus q plus 2p divided by s plus 1.
Yes.
Right.
Got it? That's it. Right? This is the general case of all of them. Okay. So, yeah.
Sir, why 2p?
This is the formula 2p because you're applying the padding 2 times, right? Once on the 2 times on the row of the see, not 2 times. You're basically, if you say padding is one layer of padding is adding here also and here also, right? Similarly, it's adding here also and here also. I have to count it twice, right? So if you remember earlier in the session when we were doing padding, we did this, right? It was m plus 4 and n plus 4 rather than n plus 2 and n plus 2. Double it was happening, right? Because you're applying 2 times, once here and once here. That's why 2p. Okay?
Okay, sir.
Yeah. Okay, so any other question on convolutions? Is the idea clear how the kernel is actually detecting a feature map, then learning it with the dot product and how the output is working? I think that is clear, right? We have taken enough examples and we have also taken the general case.
Yes, sir.
Okay, others? Any other question?
Excuse me, sir.
Yeah.
Yeah, you written 2p in the formula, like we have only p, right? Or something like.
No, 2p. 2p is the formula. It's not p. It's 2p only. See?
In the actual, okay, 2p is the formula. Okay.
Yeah, 2p is the formula because you're applying the padding twice, right? If you apply it once on both the sides, it's getting applied, right? That's why 2p.
Okay, got it. Thank you, sir.
Yeah. Okay, so that was about this. If you are through with this, most of the theory and the numerical questions on CNNs will be pretty simple. Okay, this was the main thing. Okay, so I think now let's go back to the architecture. If you remember, we had drawn this architecture and we had already seen this layer. So I can maybe do it with another color just to mark it. This we had done, the input, which is the image understanding. Softmax is something we already know, so I'm not going on this. This we have done. So let's come into this. So after a convolution is applied, we have something called as pooling. Okay, that is the next layer. So what happens with pooling? Pooling actually is a very simple thing. Like if you want to calculate pooling, it's a very simple thing. Again, you have two things in pooling. The first thing is actually not even two things. You just have one thing. Suppose you have had the input. Okay, so let's assume there was some input. Okay, and you passed it through a kernel. Okay, and then you have learned a feature map, right? Feature map has been learned. So let's assume this is the feature map which the kernel has learned after applying the kernel and padding and everything. Now what happens is this feature map I will pass through a pooling layer. Okay. What the pooling layer will do is there is no filter or no parameter in the pooling layer. What it will simply do is it will do a simple mathematical operation on these numbers. There are three possible operations that are there. One is max, one is min, and one is average. Okay. So let's assume we'll do all the three. Let's first start with max pooling. So can you tell me what's the output of max pooling on this?
7.
Simply take the maximum number. What is the output of the min pooling on this?
0.
0. And what is the average pooling? Whatever is the mean of all this, right? That's the average. 10 by 4, I think, will be the average. 2.4. Got it? This is the min, and this is the average. Okay. So whenever we have a feature map after the convolution, we pass it through a pooling layer. There are 3 types of pooling layers that are possible. The most common is max pooling, but the other 2 types are min pooling and average pooling. If I have a max pooling, I'll simply take the maximum of all the numbers. Okay. If I have a min pooling, I'll simply take the minimum of all the numbers. If I have the average pooling, I'll take the average of all the numbers. I think the operation is clear, right? Any question on this?
Sir, but why do we need pooling? Is there any objective?
Yeah, I'm coming to that. So why we need pooling is because number one, if you see the convolution layer, the earlier convolution layer, suppose this is the convolution layer. So when you have a convolution layer, you have to stride multiple kernels to learn multiple things, right? And if the images are larger, I'll have to make the kernels large also because I need to learn more, right? Larger kernels will help me multiply more features and learn more. So if I have larger kernels, do you think I have more parameters? I do, right? Because I have to learn all the values, right? All
Yes,
these values
sir.
to learn. So if I have a 10 cross 10 kernels, I have to learn 100 values, right? And if I have 30 such kernels, I have to learn how much? 3000 values, right? For just simple learning of the features. So that's why what I need to do is I need to make the images smaller. I need to shrink them, okay? And to shrink them, we use pooling. So basically what we had was, we had a 4 cross 4 feature map, sorry, 2 cross 2 feature map. With the pooling, we have shrunk it to 1 cross 1. So now that I have to use a kernel, I can simply use a one-dimensional kernel, right? Just one value and multiply and learn more. So suppose 2, right? So I just have one parameter here. Okay. So what does pooling do? Pooling helps in shrinking the dimension. So it shrinks the dimension. And this shrinking of dimension actually helps the model learn faster by reducing the number of parameters, reducing the memory requirements and all those things, which we can talk about. Okay. That's the thing.
Sir,
Sir,
how
even
on
if we are
average?
shrinking the dimension, but I think we are still picking the more intense intensity.
Yeah, that is the
will be
next
high.
point. Why is max pooling the most popular? Because we are picking the pixel value which was the most intense. So generally the features that we want to see in the images are the intense features, right? That's why if we do the max pooling, whatever was the most intense feature value, we were picking up that. So out of all these values, this was the most intense feature value, right? 7. So this had the most intensity. And that is why max pooling picked the 7. So that is why all these pooling strategies have been tried. Max pooling is the one which is the most popular because it also helps you to get the best value and also reduce the size at the same time. Okay.
But sir, translation by variance, how is it helping the pooling?
Translation variance as in what is that?
If the feature is, I mean, not in the center, let's say it's in the side, in the corner of the picture.
Yeah.
So pooling will help that to pick up.
Yeah, it will. We'll come to that, how it will help. We'll take this example for that. That's why I've kept this example. Now, basically, see one thing important. Whenever we have max pooling, like what is the max pooling on this? Can someone tell me what is the max pooling on this?
8.
It will take the the maximum
8, right? So if we apply a simple max pooling on this, the output is 8 because we have taken the maximum feature, right?
Yes.
Now the question you are asking is very correct. That the maximum value is occurring 8 here, but I also have a high value here, right? Which is towards this. I have a high value. This corner has a high value 4. These are also values which can be important actually, right?
Yes.
Isn't it? So while I'm doing the max pooling, I'm not even giving anything to this. I'm just ignoring all this. I'm just learning this part, right? So that is why when you do max pooling, you don't do the max pooling directly by taking the maximum on the image. What you do is you assume there is a hypothetical kernel and you stride that kernel to do the max pooling. So let's assume, I think that was a pretty heavy statement I made. So let's see what that means. So suppose I have this here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What I'll do in max pooling is I will give the max pooling 2 things, not even 2 things, just one thing. I'll tell the max pooling that do a stride, okay, and I'll also tell the max pooling assume a filter size. I'll again repeat, max pool does not use any filter. It will assume a hypothetical filter and stride it. So suppose I have a 2 cross 2 filter with stride is equal to 2. What will the max pooling output of this? Can someone tell me what the output is going to be? Just try a 2 cross 2 filter and tell me what the max pooling
5,
output is.
8.
Yeah, so first it will go here, 5.
Sorry, 6.
Yeah, 6.
6.
Then it will go here, 8. Then it will go here,
14, 16.
14, 16.
So basically now if you see, I have picked up important values from all the sections of the images, right? If you see this. I have picked up something from here. I have picked up something from here. I have picked up something from here. I have even picked up something from here. And I have also reduced the image size. So if you see, this is the 4 cross 4. and here I have a 2x2, right? I have half the image size also. So that is why max pooling and average pooling and all these poolings, they are not done over the entire image. You assume a hypothetical filter size, you assume a hypothetical stride, and with that you do the max pooling or min pooling with that. There is no filter, okay? There is no kernel here. I'm not learning any kernel. I'm just assuming there was a kernel and just striding it and just picking up the maximum values. That's all. So is the idea clear? What am I trying to do here? Is the concept clear? What the hypothetical filter
Yes, sir.
is here?
Yes,
It's
sir.
clear, right?
Yeah. Sir,
Okay,
in the
can you-
previous slide, sir,
Yeah,
I
yeah,
want to ask one. In the previous slide, you calculated average. So I'm not getting like how you're getting 2.5, like because you said average. So 10 by 3 must be like
10 by
10
4,
by
right?
4.
10 by
1,
4.
2, 3, 4. 4 elements, right?
Okay, sir. Thank you.
So average is what? Sum of all outcomes by number of outcomes, right? So number of outcomes is 4 here, right? 1, 2, 3.
Yeah,
4. The sum is 10. So 10 by 4. Okay. Count the 0 also, because 0 is also an element, right? So in the sum, obviously, it doesn't count, but in the count of the numbers, it will get counted.
Yes, sir.
Okay. So, yeah. So any question on this? Is the idea clear what we are doing here?
Sir,
Yes.
I have one question here.
Yes.
So, sir, as you said that we have to assume hypothetically there's a, like, let's say filter to, I mean, there's like stride of 2, right?
Yes,
So
yes.
does that mean we should not pick, I mean, if like question is asked that what is the max pooling for this? So should I
Yes.
first try to, I mean, calculate and see whether stride 2 would fit in, or can I just directly pick by looking at the max number from this?
No,
Would
no,
that be
max number you
correct?
can pick directly.
Okay.
You just have to, this will be the stride and the size of the filter will be given. So once these two are given, you can pick up the maximum directly. Okay.
And okay, sir, and if those are not given, then
They will
still
be
we can
given.
pick the.
No, they will be
Okay, sir.
given always. Yeah, yeah. We'll not give anything which is confusing. Everything will be given. Okay. Yeah.
Sir, I have a question.
Yes, yes.
So we are talking about images here. So is there a logical equivalent when we process text data, which is similar to pooling?
We don't do any pooling. Text processing is completely different. You learn it in week 5 how it is done. There is no pooling required for that.
No,
Because
no,
in text
I'm
processing, the
not saying
dimensions are
pooling
much
is
smaller.
required, sir. Sir, what I'm saying is that pooling basically captures, let's say, the most intense features, right?
Yes,
That's the
yes.
logical definition for pooling, let's say.
Correct.
So is there then equivalent or analogous thing which we do when we
Yeah,
process
there is,
text?
there is. It is called as embedding. So when we generate embedding, there are multiple ways of generating an embedding. So there, if you use the good ways of generating an embedding, you can capture the best possible features in the text. Yes. So embedding is called that. That is called embedding. Okay.
Okay.
Yeah.
Sir?
Okay. So any other question on this? Okay, tell me one
So,
thing. Tell me one thing. Yeah, just a minute. Tell me just one thing. On this image with this filter size of 2, stride is Z2 and padding is 0. Can you tell me with the CNN formula, is the 2x2 coming correctly from that formula also? The formula which we learned a little while back. Is this 2x2 coming correctly from that formula as well, or is it different?
It's correct.
Correct, right?
same, correct, sir.
Minus 2.
4
By
minus 2 plus 0 divided by 2 plus 1.
Plus
Yeah,
1.
this is
So
1
this will be
plus
1
1.
plus 1. We have 2.
Right? Correct. So
Yes.
that means this CNN formula which is there, that can also be used for max pooling. So you can even calculate what is the output dimension after pooling, right? So that formula can be used anywhere. So that's what I was trying to say. That formula is not only for the kernel layers, it is for even for the pooling layers you can use that formula. So that's going to give you the right answer. You just need to know the stride and the filter size. Yeah. So any other doubt now?
Here, this pooling.
Yeah, one by one. Yeah, pooling. What you were saying?
Yeah,
Pooling.
this pooling, how it's not losing the actual features.
It's not
Because
losing,
we are
right? It is not losing. It is, see, it will not retain everything because I'm shrinking, right? Once I shrink, I will lose something. It is picking up the thing which was most important. Look, for example, after doing a CNN feature map, I have this bark of a tree, and this region of the bark is most intense, right? This is the intense region of the bark where I can identify that this is actually the bark of a tree. So on pooling, what is happening is I'm picking up this region and I'm ignoring all the other regions. But I'm still getting the tree, right? The tree is still coming. I can still just see this and tell me that's still a tree. Right? That's what pooling is doing. So just assume that you have a tree image and you capture one angle of that image, which actually tells you it's a tree even without looking at the full image. That's what pooling is doing. It's picking up the best angle of the image without looking at the entire image. Okay. Getting it?
The loss is not significant. That's what.
No, it's not. The loss is there. There is definitely a loss, but it is not significant. You are still retaining what was supposed to be retained. That is still there. Okay.
Thank you.
Yeah. Any other question?
Yes, sir. My question was of that only, that some information is lost, but you said it is
Yeah,
not
some
that
is lost, but
significant.
the information which is required to actually work with the image, that is retained. Okay.
Okay, sir.
Yeah.
Excuse me.
Yes.
Yeah, I think the course is going a little too fast. Maybe you guys didn't plan for this, because I
So
know
are
that
you
this is the
talking about
first time.
the session, my session
Listen,
thing?
listen, listen. I know that this time over, this is the first time the course is being conducted. It's
Right.
rather going very, very fast, and it's like having a large learning, the what we call as learning constant. You'll never reach the aim, I think so, because in my experience, because it's going very fast. And
Okay.
the second feedback is you start with PyTorch. That's
Right.
absolutely meaningless, because those topics are not there in any of the machine learning courses, like machine learning practice, machine learning foundation, and
Yeah. I
machine
think
learning
this course
theory.
introduces
So
PyTorch and the new
let me
domain.
complete. Let me complete. So this is going rather very fast, and you have already like so many things lined up. We have like NPPs, we have quiz, we have this going very, very fast. Can you do something about it?
See, actually, I am new to the course team. I was not there when it got designed, so I don't know about it. But what I can do about it is I can contact the other instructors and I can inform them about this concern, right? That it's
Because
going too
I
fast.
don't
So what
think,
we can do?
yeah, I don't think, like if somebody is doing, because I have three other projects this term, and I cannot do justice to this course, because all that I do is I don't understand a lot of concepts, because it's going like so fast.
Yeah, I
It's
can.
really
I
hard
can
to
agree
keep
to
up.
that.
I
Yeah.
don't know why others are not, like, I don't know, maybe some others have the same feeling too, but learning this way is not going to help anyone. So, I mean, it helps somebody who has designed the course, but, it's not going to help anyone.
No,
I mean, I
actually,
see.
what I'll do is I'll tell this to the team, right, who are in charge of running the curriculum, because I'm not in charge of that. I was very new to the course. Like I joined the team 2 weeks back only, so I'll tell them about this concern, and if something can be done to make it easier, I'll ask them. Will
Because see,
that be?
what has happened, see, this field is growing like leaps and bounds. Like the
Yes.
growth is just explosive, especially deep learning, which, it was, I mean, papers started coming around 2023 when we were still doing machine learning and we were just doing statistics 1 and 2 and all that. Okay. So, but then suddenly there's a huge leap. I mean, this is something which I don't know if many people
Can
can
I
follow up.
add a point?
Yeah, please.
Yeah. So basically, as far as I have seen, I have also some industry experience. I would say that it's designed as per the industry, because you will not be able to cope up with industry. So it's designed as
Yeah,
per the industry.
let me tell you, Indian industry is just copycat. Okay, I mean, all this nonsense about innovation and all this is
See, let's
bullshit.
not
Okay.
take the discussion
No,
there.
no, no. Let me complete. I mean, see, this is a free country, and I mean, I didn't talk anything controversial, right? So, industry is the one thing we are not learning for industry. Okay, I mean, we want to learn first, and then see whether we can actually get a job, whether we like that job, or if this is the way we should go. I mean, industry is just taking a lot of projects. Okay, I understand that. Okay, so I mean, and I see a lot of job offers, asking for deep learning and generative AI experience from people who won't have any experience. I mean, this is how, I mean, they do. I mean, they study here and there a few things and then use packages and then solve the issues. That is not the way this should go. I mean, I don't care about what industry does. Okay, that's BS.
Actually, there was a feedback from Venkatesh that was circulated few days back. I think if you can fill that form, I think that will be more organized. And
No, let
secondly,
me know the team members. I'll write directly to them. Even
Could
to the
you
team
fill
members.
that from
Yeah, if there is
now
a
the
form, you
topic
can
is
fill the
going
form because the
on?
team will get access to the
What do
responses.
you
It's
mean?
like
I mean, this is where we have to talk. Who is this? This is where we have to talk. I mean, already it's like, I mean, 9:10, and this is like the extra time we are using. And where can we raise? I mean, I don't know why others are. So all of you are finding it very easy, is it?
So, sir, none of the
Yes, I think because
I
we
have
have
a
been
separate
following the
feedback,
classes. It's just
Sayan
that you
sir.
have to follow the classes,
Okay,
and I
then
know that it might be difficult. It
Python
might be a
is
bit difficult. I
also
understand, sir. So I
no, I'm
understand that
also
because
following.
of the
I'm also following the classes. I'm also reading, and I'm also
no, sir.
following the classes.
Then, sir,
It's
actually,
not that.
listen. I mean, so this is
Listen,
because we
listen,
are going
listen
off.
first.
We are going off topic, sir. We are going off topic.
No, it
We have been
doesn't
listening
matter,
to you.
man.
So why it matters, right? Because as you say, it's a free country, so it's free country for all, and it's not that
Yeah.
every.
So why
So
are
we
you not
have
allowing me to
diverse people
talk?
of background. So we have been
Why
listening
are
to
you
you.
not allowing me to talk? I mean, see, I
When
have
you
my own
said,
concerns. So
sir,
far, see,
yes,
so
yes,
far,
yes, I
so
agree.
far, so far. See, so far,
no, no,
see, you
please
are
listen
going
to me as well. I have been
to,
listening to
see, this
you
is going to
for
be a
past 10
shouting
minutes.
match if you are not going to stop.
No, no, sir, please listen. When you said others are finding it easy, that's where I spoke. I was listening, I was quiet, and I had no interest to intervene as well. When you said others are finding it easy, that's where I'm speaking. So now, if you want to hear me, then I can hear. Otherwise, I can go quiet because I have no
You are
interest.
not hearing me, right? You are not hearing me. You never allow me to talk.
So it's live streaming, so please.
Yeah, can
It
somebody
doesn't
please
matter whether it's live streaming or recorded. You can put it on the YouTube. It's okay.
So can you
I mean,
please
what do you
respond?
mean it's live streaming?
kindly let's deviate from this discussion. We can take it up later. I got your point. I'll convey to the team that the
No,
difficulty is.
I was asking only one question and there's no answer, and others are not allowing me to answer. Why is that? See, I want to know like whether I can write to the team directly and give
Yeah,
me
yeah, you
the
can. I told you, right? You can write. You can write.
yeah. So
Please
that's
write.
all I wanted to say. I mean, why all others are coming in and then talking about industry and all that nonsense? I don't know.
Please don't use a rude language. First of all, this is
Yeah,
a live
nonsense is
discussion. We
not
are all
rude language. I mean, there is much more ruder words.
see. There is something called as etiquettes and decorum, right? We need to maintain that as well when we are in a
Yeah,
public
this
setting.
is not outside the decorum. I mean, people talk about industry and all that, but you cannot skip a lot of things, right, without learning. And I've been
I
following
agree to
all
your
the
point, and
live.
I will convey it to the team. You
Yeah,
can
I've
also
been
write.
following all the live sessions, and see, one of the live sessions was so bad it went up to 3.5 hours, and I think close to that, and
When
everybody
was it?
was.
Can you tell me the
It
date?
was. I just forgot. It really went very long. Okay, this live session, and the person who was teaching was just writing code and code and code and all that, and
Shayan, it
without even
was week one. We were doing back propagation calculation. The calculation is definitely big, and we insisted that we wanted to know the mathematical background. It is
Yeah.
not.
this is
It
not
is
about
not in
Who
depth
was
in the
the
mathematics at all.
course.
instructor for that?
It was not
This
in
is not
depth in the course, but we insisted that we wanted to know how big it could go. That's why the session went so long. In fact, Pulkit got so tired, he told us, please complete that and submit the calculations on the discourse. I'll check it for you people and we'll continue the discussion there. But it was
Yeah,
on our insistence.
very
We
long. I
continued it.
mean,
So who taught that
is
session?
this
Pulkit,
Yes,
right?
sir.
It was Pulkit's, yeah, it was
Yeah,
TA's
it's okay.
class, and we
There is no
insisted on that class to be extended. He was asking
right.
us every hour that, do you want to continue? And we agreed. Aviral was there, I was there, Disha was there. We all agreed
Yes,
that
sir.
yes, we want to know it.
that's nonsense. I
Yes,
mean,
yes.
you don't understand anything and keep asking, like,
Mona Lisa
this and
saying
this.
absolutely right.
Yes, sir.
Why do you? I
That
mean,
was
see,
right.
this is not a debate. Okay, this is not a debate, and this is about like
Why is it not a
student.
debate? You are
No,
questioning our choices. So it is a debate. We made
will
a
you
choice
shut up,
that time.
please?
Listen, Venkatesh. This is not, you are trying to impose your own view and others are not allowed to talk. This attitude is rude, really.
I mean,
And
why?
this is
This
not
is
like
rude.
this.
Yes.
Yes.
Because see, you are not allowing me to talk.
No,
You
you
are
have
not.
been
See,
talking. You open the topic and you
no,
have
no,
been talking.
you're not allowing me to talk.
You are imposing
Please,
your
please,
views
please,
on us.
please.
You are telling us that the class was
But
extended
you
unnecessarily by the
took
team.
4
It was not
projects.
by the team, it was by us. It was by our request that was happening at
You
that
took
time.
4 projects.
Yes,
Why
sir.
I
others
don't
are
think so.
going to suffer? Come
See,
on.
some people may be very knowledgeable. Okay, some people may have like a extremely good idea of what is going on. I don't have. And I need to like
Then
ask some
you should have
questions. I
taken
need to
less
like you
projects.
cannot
Then
just
you
keep
should have
going
taken
on
less
like
projects.
I think the course is going very fast, and I think some people have an edge on this, and they just want to
Sir,
pull
one
No,
others
thing,
down. That's what
you
I
took too
feel.
sir,
much
one
load. You
thing. I
took too
think
many
you have
projects and
taken
courses
too
on the
many
same time.
courses at
That's why the
once.
problem.
No, it's
Yes.
not about too many courses. I have just 2 terms to complete in diploma, and I've wasted three or 4 terms just doing projects. And BDM is another,
I
I
think
just thankfully
let's
got rid
continue
of
with
it.
the session. Venkatesh, I got your point. You can make a post and discourse and tag the instructors. All the
Yes, and
instructors.
please don't say that this is rude and this is etiquette and all that.
See,
No,
you are
no,
using
I'm just
words
going
which
to
are not
write whatever
supposed to be used, right? That is what
yeah,
I'm
I'm
saying.
just going to write whatever I feel like. Okay, that's all. Please don't say this is ethic and that's not there. This is how this is rude and all that. That's just, I mean, everybody knows it's not rude. Okay, please.
That's what you think. Please, let's stop and let's continue. Close the.
Yeah, go ahead, go ahead.
Sayan sir, there is one little feedback.
Yeah.
So, sir, you were teaching today about the convolution, the formulas, and all of that, right? So
Right.
during the week also, when we had sessions, right,
Mhm.
there also this was told. So, are we doing these topics again, or what is the rationale for that? Maybe you can check that up also, because I feel that's duplicating the same thing.
So see, actually, those were TA sessions, right? So in TA sessions, they repeat the TA sessions are basically on your pace. Like if you want the coding to be discussed, they will discuss coding. If you want the theory to be discussed, you can discuss the theory. These are the instructor sessions where we do one session for code and one session for theory. This week we have done both the sessions for theory, I think, because the CNN concepts were slightly heavier and we got some feedback that if we can cover them again, that will be helpful. So that's why we are doing the theory part twice. Next week we'll do both the code sessions because next week is again coding of CNNs only. So that's why we have moved the coding part to next week for both the CNN topics. Okay, that's the thing.
And are you aware that there is a quiz coming up? And
Yeah.
how are we supposed to learn so much? I mean, I have 3 more projects, and I have only 2 terms to complete. And then see, Gen AI project. See, they said, okay, you do the next term, and I'm worried about whether I'll be able to get a diploma or not. And it's just so you're just pushing so much of material, and I don't think it's this not. I don't know if there seems to be a lot of people
Sir,
agreeing with
one
the
thing
speed of
I
the
want to
course.
ask, if we
Yeah,
make schedule, then we can go with our projects and courses. If we don't have any schedule, then we are not able to manage anything.
yeah, but I don't understand what is even being taught today.
Actually, I have also two projects. If we manage and manage the
No, I
thing,
don't
then
think
we are,
you'll be able to manage. Go ahead with the
no.
subject, please. I mean, because
I have
we are
also two
already like,
subjects.
yeah, please
I
go
have
ahead with the
also two
subject. Yeah.
subjects. MLP and DL. I have also two subjects. If we go with the schedule, like how we can do,
I
like
think, yeah,
when
I
we,
think let's continue with the
then
lecture. Yeah, I think let's continue with the lecture.
Please, sir,
then
go
we
ahead,
can go
session.
ahead. And sir, please
Do not
continue.
the break piece of the break of the session. Please go ahead, sir.
Yeah, okay. If everyone is ready, I can continue. Venkatesh, just last thing, you can write your feedback. There is no problem about that. Okay, we will
Yeah,
definitely
yeah,
go
I'll
through it.
write the feedback. I'll write the feedback. I'm
Yeah, and
sorry to
we'll go through it.
have dragged
No, no,
on.
it's okay.
Please
It's okay.
continue. Yeah.
We'll go through it. Yeah.
Apologies. Yeah, go ahead.
Yeah, no issues, no issues. Okay. Yeah, so if everyone is ready, shall we continue then? All
Yes,
good?
sir.
Yes, sir, continue.
Yes, sir.
Okay.
Sir,
So
I have
let's.
a doubt.
Yeah,
In previous slide.
read this one.
Yes, sir. Sir, here you explained about max, min, and average. In last two, you have written one parameter. Could you please explain that part?
Which parameter? This one.
Yes, sir. At last, you.
No, this is, I'm just telling that after pooling, if you just reduce the size of the image, right? So when you take it to the next convolution layer, you can use a smaller kernel for that. So once the images of size 1x1, right? So in the next case, you can use a kernel in the next convolution layer, which will also be 1x1. So that will only have one parameter. Okay, this is not for pooling, this is for the kernel. We were talking about convolution kernels there, right? That's what I had written there.
Okay, sir.
Okay, yeah.
Sir, I think there is one more polling method. The name is adapt max. It is a global type.
Okay.
Max adaptive something. I'm not.
Yeah, add a max pooling, right?
Yes.
Right.
So, sir, what is that means? Can you explain that?
In that, what happens is you basically do a combination of max pooling and average pooling for certain kernels. Like in the first slide, you do a max pooling, then you do an average pooling in the next kernel, and so on. Like suppose this one will be the max pooling result, this will be average, this will be max, this will be average. Mixture of both of them.
And at the end, it gives a 1:1 dimension output.
No, dimension will depend on what the size is, right? And you will again use the same kernel formula for the dimension. It will depend on the size of the kernel and all. So dimension is fixed based on whatever kernel size and style you're using. But the way the pooling is done, that changes, right? Instead of taking maximum for all of them, it takes maximum, some it takes average, and so on.
Okay.
Okay.
Yeah,
but that pooling we will not use here. So yeah, it is a valid pooling, but whatever we will use is mostly max, min, and average in our course. Okay.
Yeah.
Simple one.
Yeah. Okay, sir. Thank you.
Yeah. Okay, so to coming back on this slide, we have basically now covered the convolution layer. We have covered the pooling layer. Okay, so that is what this picture was having. So we are basically having convolution layers. Then we have pooling layers, which is basically shrinking, right? So at every layer, the output is shrinking. Why it's shrinking? Because we are using that CNN formula, right? So I think now you can understand why the output goes smaller and smaller at every layer. So once we have placed all these convolution layers and all these pooling layers one by one, in the end, we have something called as a flattening layer. Okay. Now, what is the flattening layer? Flattening layer is very simple. It does nothing actually. So let's assume this is
What is the purpose of multiple convolution and pooling layer?
Yeah, the multiple purpose is that just like in a neural network, you have multiple hidden layers, right? So why do you have multiple hidden layers? So that you learn the more complicated results well, right? That's why we have more hidden layers. That is why we have more convolution and pooling layers, so that you learn it better.
Okay. That you do it with multiple filters, right? You already in the first layer.
Yeah. Multiple filters. Yes.
Multiple filters in the first layer itself. You will be.
Yes. Itself.
Why do you want to have more convolutions? You put all your filters in the first itself.
That means what you're trying to say is you put all your filters, the filters here, and remove this layer, right?
Yeah. N1 and N2 is enough. You have two N1s and two N2s.
Yeah. So that is true. N1 and N2 are enough. So that is an architectural choice. You can have one layer with 45 filters and you can have 3 layers with 15 filters. It is the same thing. Okay, it is an architectural choice. Generally, what people have observed after working on convolution neural networks is if you make it deeper after applying multiple convolutions and pooling successively, it gives better results. That's why the architecture is like this. There is no fixture. You can even have one convolution layer with 45 filters and one pooling layer after that. And that's it. That will also work. Okay, it's just a choice.
Okay.
Yeah, so most of the conventions in machine learning and deep learning, they are experimental results. So they are basically drawn from research paper conclusions where some researchers have got that this method is better, some have got that this method is going a better result. So that is how we have arrived at these normal conclusions, right? So why is ReLU better than sigmoid? Why is ReLU used more? Because the experiments have shown that ReLU gives better result. That's why we use ReLU. Okay, that's the idea. So everything that we are learning, it's all decisive. You can use any combination of it that you want. It is just that the architectural choice is different for the way we are using it. Okay. Is that clear?
Yes, sir.
Yes, sir.
Yeah. Okay. Yeah. So let's come to flattening now. So in flattening, what we are doing is very simple. So suppose we had an input, okay, which was 4x4. We supplied a filter here, a convolutional filter. So this was the first convolution layer. Then we did some pooling. Okay, some dimensions and all are there. Now we know how to handle them. Then we again did some convolutions. There is some new filter here, CN2. Then we have pooling, which is P2. And that's it. So after doing pooling, convolution and everything, we finally have the last feature map, which is a simple 2x2 feature map, which is like this, 4, 5, 6, 7. This is the final output we have got. Okay. Now, what does flattening do? Flattening means what? So this is what? This is 2x2, right? 4 elements which are 2x2. What is flattening? Just simply rearrange them into one dimension. 4, 5, 6, 7. Or you can rearrange it to this as well. 4, 5, 6, 7. Okay, so instead of having 2 cross 2, you have 4 cross 1 or you have 1 cross 4. Generally what we do is we flatten them into a column, okay, like this. So this is the flattening layer, simple. Right, no learning, nothing, no filtering, no operation. It's just that the arrangement of the numbers gets reshuffled. So you reshuffle all the numbers from 2 cross 2 to make it a 4 cross 1. Just one dimension. Okay, so this is 1D. Got it? Pretty simple. So
That
can I say?
is taking up these features actually, elements.
Yeah, we are just making them normal. Yeah, we are just arranging them, rearranging them into one dimension. So if you say in general, like can I say this? Like if I had the output feature map, the feature map after some convolution, this feature map had a dimension of m cross n. So after applying the flattened layer, can I say my dimension is mn cross 1? Is this correct?
Yes.
Correct, right? Because I have all the elements, instead of arranging them into rows and columns, I just arrange them into one row or one column, which contains all the elements. So can somebody tell me what will be the flattening of this?
Mn or m plus n?
Mn, right? Mn, right? Because this is 3 cross
1 cross 9.
1 cross 9.
Yeah, 1 cross 9, right? So you'll have 9. So it's Mn, not m plus n.
Okay.
0, 1, 0, 1, 1, 1, and then you have this 0, 0, 0, right? So this is how you flatten them. Okay, now what is the use of flattening? So can somebody tell me what is happening after flattening? So if you look at this image, this is where I have flattened. What am I doing after flattening?
We are going to flip this into the...
Yeah, the simple neural network, right? A feed-forward MLP.
In the
right?
traditional neural network, yes.
Yes. So the purpose of flattening is nothing but feeding the image into MLP. So if you remember MLP, a simple neural network looks like this, right? This is what it looks like. So can this network take a 2D matrix as an input? Can I give the network this 1, 2, 3, 4? Can this be an input to this matrix, this network? Possible?
No.
No.
No, right? But I can do this, right? 1, 2, 3, 4. This is possible, right? I give 4 values of the features 1, 2, 3, 4, and I give 4 neurons here. This is possible, right?
Yes.
Yeah, that's why we
Yes, sir.
flatten, right? So flattening is done so that the image, which was a 2-dimensional or a 3-dimensional because of RGB, that is flattened into 1-dimensional so that we can give it as an input to the MLP, right? So flatten the image.
So let's suppose, sir, I flatten this matrix 1, 2, 3, 4, right?
Yeah.
So 1 will be like the first neuron, 2 will be second neuron.
Yes,
Is
3
it
will
like
be
that?
third neuron, 4 will be fourth neuron. Yes.
Okay, sir.
You can even shuffle, right? So when your code, it's all done by code, so you can even shuffle. Like you shuffle this and flatten, so this becomes 3, 2, 4, 1. Anything is possible. But generally, when we flatten, we don't shuffle or do anything. We just flatten it normally, right? So this becomes 1, 2, 3, 4. The normal.
Okay, so I thought that we what do you say, rows instead of that single number, we are just giving the rows, first row, second row, third row, like to the first neuron, second neuron, third neuron.
Yeah. So this we are giving. No, not row, not row. We are giving a single number. Okay.
Okay, single number.
Yeah, single number, not row.
Thank you, sir. Yeah.
Yeah.
Sir,
Okay.
will it make any difference in the prediction if we shuffle the image?
See, again, this is a question which you have to experiment and see. Generally, there is, because the idea is whenever you have an image, so think about it like this. You have the sun here and you have the tree here, right? And you have learned, the kernel has given you an output which is about something about the sun here and something about the tree here. And now you have shuffled it. So your tree goes on top and sun goes on the bottom. So is the same or is it different? What do you think?
Different.
Different, right? Because now your image is being treated like this. So you have the tree on top and the sun is here. This is not true, right? You have to have the sun on top and tree in the bottom, right? That's how the nature will work. You can't have a sun in the bottom, right? So generally, if you shuffle, you will lose some information or you will learn something which is not normal. Something irrational will be learned, right? Got it?
Okay. Yes, sir.
Yeah. Okay. So
Sir, I have one question,
Yeah,
sir.
sure. Yes.
So, sir, because I think I understood that the objective of flattening is because that's how it will be passed through the neural network, right?
Yes.
But, so, sir, I mean, until flattening, so can we say that this is all, can we consider this some sort of like pre-processing, all these like
Yeah. You're pre-processing the image data into data for the neural network to learn. The last layer. You're pre-processing it. That is
Okay, sir.
flattening, right? You're
Okay,
just
sir. Thank
processing it. Yes. No learning. There's no machine learning that's happening here. You're just processing it. Simple processing. Okay. Yeah. Okay. Now I have a question for you.
Why we need final MLP layer?
Yeah, that was my question only. So why do we need an MLP? Like I have flattened it and then I have an MLP. Why do you think we need an MLP? Can
We are
someone
classifying that is the end goal of us, that
Exactly.
we are given an unknown input image and we are trying to find out what this input contains.
Yes.
So that is our end goal, to classify it, actually
No,
identify
why
what that image is
patterning
about.
even? Why we cannot classify the machine? It should be able to learn, right? You give, you have
It
filters.
has learned. It
Feed
has
it.
learned. Yeah. I'm
Yeah.
telling you one thing.
Make
This feature
make
map,
another filter to all this 9 multi class. Make a filter for each class and then learn.
correct. Your logic is correct. Absolutely. Tell me one, like basically what I'm trying to do is, suppose I have four. Let's assume we have four classes, right? So 1, 2, 3. This is my final feature map. Okay. After CNNs, all the convolutions and pooling, and I have four classes, which is apple, orange, mango, and banana. I have to classify. Can you do a softmax on this image? To do the probabilities, you need a softmax, right? To get the probabilities, to do the classification. Can you do a softmax on this?
I'm
Softmax
not
is what?
sure, but I can make a filter for apple, filter for orange, because these are all known things, right?
You get a filter. What will a filter give? Can a filter give you probability? Suppose you make a filter. You make 4 filters. One is apple filter, orange filter, mango filter, banana filter. How will you classify using the filter?
No, match, right? Filtering what it does. Intensity you can see, right? You do the
Filter.
same
What will the
multiplication and
filter do?
addition
Filter
and
will give
see
you
what
some
is it.
value. You will
No,
slide some kernel. You will do some
make
dot product. You get some value.
Sayan, just a minute.
Yeah.
Let me put my thought process.
Yeah, sure.
Apple, right? Apple. Okay,
Yes.
apple filter. What is the maximum value for apple filter? Say, for example, it is 10. Orange is 16. Mango is 21. Banana is 40. You just compare and see what is the value. That's it. Is it close to 10? Say apple. Close to 16. See, this can be done, right?
So how will you know it is close to 10? It has to be apple.
Yeah,
Close to
this
16.
filter multiplies, right? You make a filter such a way that it multiplies and see what is the value coming out. Your filter will be having 2 cross 2, right? Again,
Yes.
or 1 cross 2, whatever it is, you keep it.
Correct.
And then same way, like you did it for the convolution layer, do the same thing at the end also, and
Okay,
see
I
what is
agree.
the value.
Now
Compare it,
assume.
and then you will be able to do it.
Assume this is a mango image. Okay. Assume this is a mango, right? And you said 16 should be the threshold for mango. That I've got a good filter, and the filter tells me it should be 16 or close to 16, right? All the mango images that I gave are very intense mango images, so you get values close to 16. Now, for example, I give you a mango image of a green mango, raw mango. Will I get a 16 value with that?
I'm not too sure. You have to have a filter for if it is
So
apple.
you have to design filter for everything, right? You can even have a half-eaten mango. What about that? A half-eaten mango is also mango. It's not an apple, right? What about that?
I'm not too sure how flattening is helping this. I'm not too sure.
No. What I'm saying is, if you are saying we do some experimentation, design an excellent filter which takes the final feature map and multiplies, and it gives some value which tells us what the image is. Like if it gives you value 16, it's a mango, right? That is okay. But a mango image can be of 1,000 types, right? You can't have a single image describing what a mango is. You can
This
have
problem don't you think this problem should also be true for flattening? Even you flatten, you will have the same problem.
We will have the same problem, but there's a solution for that. That
we
will
should.
come to. But did you understand that why the kernel method will not work with the hard coding? Because we have a lot of variations, right, in the images. So we cannot hard code one simple kernel that will give me a universal result all the times. Right? What happens in case of MLP is after you flatten and you pass it to a simple network, this network which is looking very simple, it's not a simple MLP, it's a very dense MLP. So you will have 1,000 neurons here, you will have another 1,000 another layer, another 1,000 another layer. And what you do is whenever you increase the neurons, again learning is happening. So after the flattening, I'm again shuffling, sorting, and I'm learning a network again. So there is a full neural network learning that's happening here as well. Right? And we already know.
Either you do this way or you put a filter, proper filter, and then do it.
See, there is no one filter, right? You have to put multiple filters in for doing it. So if you have the time to design and if you have the computer resources to design so many filters, yes, you can do that. But better than putting 1,000 filters where I have to think about which filter will be doing what is the threshold in this case, what is the threshold in that case. If I build a deep network which is just learning the numerical features and giving me a probability for all the classes, isn't that better? That is better, right? What do you think? Like others, you can also give your opinion. What do you think? Which is a better method?
I'm not able to convince myself. I need to understand much better. Okay, but we will leave it there and then move on. Yeah.
Yeah, see, convincing is pretty simple. Just try to understand whenever we have a network which is very deep, right? A simple network which is very deep, that network tends to learn a lot of different combinations and it learns more robustly. If you have a filter, you have to hard code the filter, right? You have to assume that this filter will look like this, then only I'll get an apple with this value. So you have to think yourself and you have to experiment with multiple filters. And even if I change the image a bit, I will lose out on information and the filter might give me wrong result. But on the other end, if you have the MLP is going to combine different values with all these weights and biases, and then it is going to do some combination and learn, right? So the accuracy that you get with the MLP is going to be much better than the accuracy that you get with the filter. That's the point. Your method might also work. I don't know. It might work, right? But the problem is you have to have too many filters and too many assumptions for that. Okay, and then you have to make a very deep filtered layer again, which will again increase so many parameters. On the MLP side, you just have to have 2-3 hidden layers and some neurons in that, and that's it. You can shuffle and sort and learn it. That is the main objective, right? Think about it. Like you think about it yourself also. You will come to the conclusion.
I need time. I need time to process this.
Yeah, sure. So think about it, but take my case also. Like whatever I was telling, just take that into mind as well, and just think about it using that. Okay.
So one thing we can do is take these two both approaches and try it experimentally.
Yeah, you
so-
can. That is how research papers comes out, right? You can experiment on this. Maybe after your experiment, we will replace this with a filtered layer, and the next batch of the course we'll treat it as a filter layer rather than an MLP, right? So that we can do. But currently, based on the current experiments, it has been prescribed that if you use a feed-forward layer, which is a normal MLP layer in the end, the results are much better because you learn much more robustly. Okay. And the motivation is one object can have multiple images describing it, right? The eaten mango, the peeled mango, the raw mango, the ripe mango, all these are mangoes, right? In the end. That is the point. Okay.
So basically, we are using CNN to make better inputs. Like, is that where?
The main idea is if I say, I'll say this and you tell me whether it's correct or not. The CNN layers, which are the convolutional filters and the pooling and the flattening, can I say that these layers are actually used as a feature extractor?
Yes, sir.
Because basically I'm just extracting the features, right? With the kernel, I'm getting some feature. With the pooling, I'm extracting the most intense one and I'm getting something out of it, right?
Yeah.
And after that, I'm using these extracted features into this as the final classifier.
Yeah.
Is it right?
Yes.
Right. So if I have this image of the digit 2, with the CNNs, I'm extracting this curve, I'm extracting this black color and everything. And then these things are flattened into the numerical features, these values. And then this final classifier is classifying that this is digit 2, image of digit 2 with the probability of 0.95.
Yeah.
That's what I'm doing, right? Yeah. So till here, whatever you have till here, I'll just clean the slides, become a little cluttered. Whatever you have till here, this is a feature extractor, which is actually extracted the numerical features using the convolutions and the pooling layers. Then I flattened these learned features and I put them into a MLP neural network, a normal neural network, to finally combine all the features and classify the image. That's what I'm doing.
Okay, sir.
Okay. Yeah. Others, are you convinced with my point that I can use it as a combination of a feature extractor and a MLP classifier? Is that correct? Yeah, right? Okay.
Yes, sir.
Yeah, so this was mainly about the CNN architecture. Let's move into one more thing about this only, which is going to be pretty useful for your exams as well. Let's try to calculate the parameters in a CNN, right? So if you see, the CNN has 4 major components. One is convolution, one is pooling, one is the flatten, and the second is the fully connected MLP layers, right? So let's try to calculate what parameters are there in each layer. Okay, let's start with convolution. Can you tell me what are the parameters in the convolution layers? Like, what is the parameter? Weights, right?
Weights. Yes.
What are these weights? And bias also, of course. What are these weights and biases?
Filter.
Yeah.
Filters.
Filters. Yeah.
The filters are weights and biases. So if I say, let's assume the input is m cross n, filter is k cross k, stride is s, and padding is p. So can you tell me what are the parameters in this first convolution layer?
K into K.
K into K, right? Not K, K into K. Because these are the parameters. This is the first weight, second weight, third weight, 4, 5, 6, 7, 8, 9. So 3 into 3. I have 9 parameters, right? I have to learn all these 9 values. So basically K into K. These are the parameters, right? What about the pooling layer? What are the parameters in the pooling layer? What do you learn in pooling?
Nothing.
Minimum, maximum,
average.
But do you learn anything? Do you learn any weight, or is it a fixed thing that you're doing?
There is no learning happening in pooling layer.
No learning, right? So no learning.
Intensity, we are like.
Yeah, but we are not learning any parameter, right? The thing is fixed. You have an image, just try it and get the maximum. We are not learning any weight there, right? No weights and biases there. So no learning.
Yes,
So
sir.
just has 0 parameters. Nothing is there, right? For learning, we are just doing a simple operation. This is a simple operation. No learning. And what about flattening? Is there anything learned in flattening?
No.
No, right?
No,
Because
it's
you
again
had this.
rearranging.
Yeah, you had this and you're just converting this into this. So there is no learning here as well. It's just shuffling. So nothing in
Because
flattening.
you know have weight and bias.
What has weight and bias?
I am thinking because you know weight and bias, it is
Yeah, correct. No
parameter is
weight and bias.
zero.
Right? We are just shuffling them. There is no weight and bias, right? Correct. And what about the fully connected layers? Are there any parameters inside this?
Yes.
Yeah, so here you have the entire thing, right? The weight matrix and the bias. So all the parameters. And that we have learned already how to calculate, right? So if you have 10 neurons in the first layer and 20 neurons in the second layer, we have 200 parameters, right? 10 into 20. 200 weights are there. Right? Last week we did this, calculating the parameters of a fully connected layer. So whatever parameters are there in fully connected layer, they are the same. There is no change in that, calculated normally. So just calculate this normally. All right. So that means to end with, whenever we are talking about CNNs, we have parameters in the convolution layer, which is basically the filter. So all the weights in the filters are the parameters, and we can even add biases to that. In the pooling layer and the flattening layer, we don't do any learning. We are doing some simple mathematical operations. So there are
In the
zero parameters.
convolution, what is the bias?
Bias is number of filters. Each filter has one bias. Okay, so B is number of filters.
What it helps? How it helps?
It's just a constant to smoothen the values. It is not a mandatory thing. In CNNs, we don't use bias very much. Very rarely we use them. Okay, so mostly we don't use bias in CNN. But if you use the bias, there is one constant that gets added to all the weights of the filter. Suppose this is a filter which has weights 1, 2, 3, 4, and I say bias is equal to 1. I'll just add 1 to all these numbers. But it doesn't make much advantage while doing this. So in CNNs, like in the question, if bias is required, we'll mention that. But in generally in practice, we don't use bias much in CNN. Okay, it's not very useful. Okay.
So in convolutional layer, K cross K is kernel, right? Kernel.
Yeah,
weights.
kernel. So whatever was the kernel, like 3 cross 3 is the kernel dimension. So I have 9 parameters, right? Because I have to fill 9 elements in this matrix, right?
Yeah. Every
I'll
time.
give you a question. Just solve this and tell me. So you have 10 5 cross 5 kernels are used in the CNN layer 1. The first convolution layers have 10 cross 5 kernels. Calculate the parameters inside this. Can someone give me the answer for this?
250.
250 plus the
250,
number
right?
of
Because
biases.
250.
for each kernel, I have 25 weights, right? 5 cross 5.
Yeah.
And how many kernels I have? I have 10
10.
kernels, right? So I have 25 weights for 10 kernels. So I have 250. This is the weight. Let's assume it has bias. So how many biases will be there?
10.
10 bias, right?
bias.
Because each kernel will have one bias. So add 10 to this. So what are the total
Yes, sir.
parameters? 260. Right? So if there was no bias, then I have 250. If I have bias, I'll add 10 and I have 260. These are the parameters, right? So these types of questions you can expect in your exam also. So this is pretty important. You have to solve this closely. Okay. One more question. Let's solve this also. We have 2 cross 2 kernel with stride 2, padding 2 in a pool layer. Okay. In a max pooling layer. So calculate parameters inside this. Yeah. Anyone?
Zero.
There would be zero parameters.
Zero, right?
Zero
Because it's a pool
parameters.
layer.
There's no
Straight away.
nothing
It's
happening.
a pool layer, right? There's no learning. This does not matter. Whatever this is, this does not matter because there is still no learning, right? I'm not learning anything. I'm still going to do max, min, and average only. So no learning, zero parameters. So this is always true. Pool
So this was a
always.
tricky question.
Yes. This was a tricky question. I agree. You can expect something like this also. Pool always have zero parameters. See, I can complicate the question by mentioning stride, padding, and everything, but you just have to remember it's a pool layer. So whatever you have, it doesn't matter. I have no parameter. I'm not learning anything. Okay, I'm just doing an operation. Okay.
And if it's not a pool layer, simply CNN, then
Then you multiply, you do 2 into 2, and then you multiply it with the number of kernels, right? And you get the CNN parameters. Just do this now. Whatever you did here, do the same thing here if it's a CNN layer. Okay. So see, whenever you're calculating parameters, see what layer it is. One, if it's a CNN layer, convolution layer, then there are parameters. If it's a pooling layer, then there are no parameters. Okay.
Yeah. So we have to calculate like normally, then we have to find in the last like.
Yeah. Normally you have to find.
Yeah.
Yes.
Taking 2 at a time.
2 at a time. Yes. Yeah. So there are questions on this in the GA. Just attempt them GAPA questions and you will get an idea. The procedure is same. Okay. Whenever you see pooling, straight away enter a 0. You don't even have to solve it. It's free marks. Okay. If you have a pooling question. If it's a convolution question, then you do the multiplication and solve it. Pretty simple. That is also not very difficult. Okay. So is that clear?
Sir. Yes, sir.
Yeah, one last topic is there, which is data augmentation that we will take up in the next session, because in next week the theory part is pretty light. So I'll cover this in the next week, because I think today's session we have covered a lot of things. So I'll open the session for questions now, like general questions if you have, and then we can cover this in the next week. So this we'll do in week 4. Augmentation is nothing but it's just making different images from one image, right? You color an image differently, you flip it, you rotate it. That's what is augmentation. So nothing very special, but what it is, we'll see more technical details of it in next week. Yeah, so somebody raised hand. Yeah, Karthikeyan, yes.
Actually, my question is, it's not a question, but regarding the one discussion we had before.
Yeah.
See, the first few weeks, it's too heavy. So mainly heavy, no, if it is only theory or only coding, then it would have been.
Yeah, you are actually doing both the things
But
together, right?
it
That
is
making
really
it difficult.
intense. This feedback needs to be taken, and the
Sure.
course needs to be considered for maybe 2 or 2.5 weeks, can be 4 weeks. If you put both the theory as well as the coding part of it. Because the coding itself it's nothing to do with theory. It's completely different, because you're introduced to libraries. And
Yes.
I'm still not conversant still. And
No,
there is
don't worry about it. I will
no
take this
code
feedback.
along with the tutor. There is no coding first approach we are taking, because these things for me, whatever I come to the class, whatever time I spend on the class is the only time I spend for this. I don't go to the lectures and things like this, because I don't have time for that. So that's why you should take Mr. Venkatesh's feedback and then do something about it.
I will take that. Yeah.
Okay,
I will take his
thank you.
feedback. Yes. We will have a discussion on this with the team. So don't worry about that. Okay. What we will do. But I hope the theory part is clear, right? At least what we are covering in this session.
Theory is very clear, but
Yes, sir.
the coding is also,
Yeah,
right?
yeah.
It's not just theory. Theory is just understanding the concept. But
Yes.
the real
I've taken the feedback. Don't worry about the coding.
only by coding, right? The
Yes,
coding
yes.
part is also you need to equally conversant to do something useful. What you learned, right? Learning, you can do a lot of learning, but unless you put that into something, to put that into something, the coding part is necessary.
Probably, Sayan, you could take one coding session also, along with your theory sessions which you're taking.
Yes, sir, right.
Yeah, okay, sure. We'll
Yes, sir.
arrange something on that. So don't worry. What I'll do is I'll contact the other instructors today, the team, and we'll have a meeting on this, and then we will see how we can make it easier for you. Okay.
Sir, we can have one more session on Sunday. It is
So
free.
like PyTorch.
Yes, sir. Sunday.
Yes, Sayan, a reminder that you were planning to shift your timing.
Yeah,
We
that will
requested you to
be
shift your
effective
time.
from next week probably, because for this week there was some engagement from our side on Sunday. So next week onwards we will shift the session to Sunday probably. Okay, so that I have taken into consideration. This week we had some logistical issue actually. That's why we could not shift it. Next week onwards we'll be doing that. Okay, that will be done.
Like Sayan, how you go with theory, right? You break it down into pieces, and then you try to throw lights on each and every pieces of these concepts, right?
Yes.
Likewise, we need the same kind of similar session for the PyTorch or Tensor, whatever, because these are all conventions. Somebody has already designed it. We are learning completely new. So we need to get conversant. You need to have hands-on. So we need to code along with you, and we want to understand the same knowledge what you have. We want the same knowledge to be gained, right? So that is, we need some session wherein
Do
you
we
break into pieces and then let us understand. This is what I think Mr. Venkatesh is trying to
do
explain.
we have NPP or anything like for this subject, for this course?
Yeah, we have 2 NPPs. Yes.
When is there any date like announced?
I think in grading doc it is mentioned. Anyone knows the date? Like I have not checked the
No, there's
grading doc yet.
no date that is being mentioned. They'll say
So it will happen after the quiz one. If there is no date mentioned, that means we'll give you more time. It will happen after quiz one.
So
Like
it means if
tomorrow quiz
NPP
two
happen,
comes up.
then quiz 2 will not happen, right?
No, quiz 2 will also happen.
So
1 minute.
many.
Do you see the portal? No? Just see the portal.
There are 2 NPPs for us in this course, along with 2 quizzes.
Yeah. This actually, see, this
Oh.
course uses the same approach of another course in the degree level, which is deep learning practice. That is also a similar course.
Sir, on course intro, probably.
Where am I? Achha, I'm on the disciplinary.
Disciplinary.
Sorry.
Grading box.
So let's see
I
what
don't
is
think there are
mentioned here.
dates available in this document. It just mentions.
Okay, date should have been available. I think there might be something.
No, sir,
somewhere.
it's not
I've
there.
seen it somewhere, but I don't remember that. See, it just says that 0.15.
Yeah, it's not available. Yeah, it's not available.
But I saw it somewhere. I don't remember, but not in
I
this.
think Levin sir told you about the date yesterday, right? There was some discussion yesterday about the NPP.
Not exact date. He just told us that NPP will happen most probably over a weekend, and we'll be most probably given 24 hours to complete it. That was all that he mentioned. He didn't mention any date yesterday.
Okay. So see, at least it will not happen before quiz 1. That is for sure. So least it will happen is 1 week after quiz 1, not before that.
Is it some open book type or anything like?
Yeah. So what will the process is going to be like? Actually, sir is doing that. But what I have an idea about NPP is that it will be a problem. Like for example, they give you a data set and they do ask you to do image classification using PyTorch, right? And then you will be given 1 or 2 days, probably 2 days. I think we will be given, and you can use the internet resources, documentations, and everything. Generate the pipeline and write the code for the pipeline to do the classification, processing, and everything, and then you get an output and you submit that. It's going to be like that.
I hope that's not tricky because the thing is even the solution is correct, but your portal is not taking a solution. So I'm facing this problem in TDS. I'm also in SC.
I think it is not going to be portal based. You have to submit your notebook, collab or something. It won't be write the upload on the write code on portal. It won't be like that.
Okay.
Yeah. That problem won't happen. It will be either on Collab or on Kaggle. One of the 2 things it will happen. Probably on Collab because it's a diploma level, right? So we don't assume the Kaggle knowledge right now because many people might not have done MLP project yet. So we'll be doing it on
but
Collab.
not on the portal because I mean it's very problematic portal.
Yeah. It will not be on the portal. Don't worry. It will be on a Collab for sure. You will have to open your own Collab and write the code and submit the Collab. It will be like that.
Okay.
Won't be on the portal. Okay, yeah. So don't worry on that. The code part will be completely on your machine. You can use any software like Collab and Jupyter Notebook and all to code it. That is okay.
Okay, sir. Got.
And you can use the internet resources and documentations also. So that is why that will also be helpful to write the code. Because obviously PyTorch has a lot of syntax, right? So we are not assuming that you will memorize the syntax and write the code. No need for that. You should know how the pipeline works, how PyTorch works, and that is more than enough to get the NPP done. That's why it's NPP, right? It's not OPP for that reason only. Yeah. Anyone else? Venkatesh, I think you have a question, right? Yeah.
Yeah. I have some general questions.
Yes.
I'll ask at the end after everyone.
Okay, sure. So others, if you have any question, I'll stop the screen sharing in the meantime. Yeah. If you have any questions, we can go ahead. Then we can take Venkatesh's question. Yeah, Anshuman, you can go ahead.
Yeah, so let's say we have a tensor, 5x5 tensor.
Okay.
So, and we have 5 vectors of R 5 dimensions. So, which one is the vector, the horizontal one or the vertical one?
Which one is the
confused.
vector?
Yeah, which one
Vector
is
is always
data
vertical.
point?
We take it vertically for the vector.
All right. I was quite confused between.
No, it's always see. Whenever you talk about vector, it has to be vertical. You will have multiple rows and 1 column or multiple columns. If you have multiple columns, then it's a matrix, of course. If it's a vector, it is 5 cross 1, 10 cross 1, like that. It's vertical.
All right.
Yeah. Yeah, Aditya.
Sir, my doubt was regarding that fully connected layer. Sir, in the fully connected layer, the WX plus B operation happens. Is that
same? Whatever you learned in fully connected before, same thing happens. Nothing different. WX plus B, ReLU, sigmoid, same thing. Nothing different. Okay, same operation happens.
Okay. And sir, learning only happens in the convolutional layer. And
Both, right?
rest.
The convolution as well as fully connected. Fully connected also has weights. Whatever has weights, they will be learning, right? That's why I did that parameter calculation in the end. Whatever has parameters, those parameters are all learned.
Okay,
Okay?
sir.
Yeah.
Yes.
Yeah, Gaurav?
So while designing a CNN, like should we be going for the complexity of each layer, or should our goal be to always try and go for more number of layers? Like, is there like a trade-off, or maybe one
There
gets
is there is again no trade-off. It is only whatever your computer and your machine can take. If you can do 10 layers with 40 filters, well and good. If you can do 5 layers with 200 filters, that is also okay. So it is all on your computer resources and the GPU. Basically, it's on the GPU, whatever your GPU can take, and rest is experimental again. That you can do the experimentation and see if is the depth increasing better or is the complexity increasing better. There is no hard and fast rule for this. Whatever suits your data better, that is good.
so for the same amount of parameters, like there's no clear answer whether
No,
more
no, no. There is
layers.
no clear answer. Yeah, yeah. You can have the same 30 parameters in 2 layers. You can have the same 30 parameters in 1 layer, right? No, no fixed answer. Both you can try.
Okay. Is there also a place, a soft spot where you can start? Like,
Generally, we start with like very simple networks like that. We learned that in week 4 also. The first actual CNN network that came up, it was called the AlexNet network. And nowadays, when we do our projects, we start from that level. So in that, we have 5 layers, 5 convolution layers using the same set of filters. The same in the sense the dimensions of the filters are same. Okay, it's called AlexNet. So just search in the internet AlexNet architecture. You'll see what type of layers we are using. 5 convolutions and 5 pooling views in that. That's the starting point.
It was AlexNet itself which successfully showed us that ReLU should be the activation
Yes,
used,
yes,
right?
correct. Yes, we use ReLU in the AlexNet. Correct. Yes. Then came advanced models like VGGNet, which is 18 layers, then RESTNet, which is more than 150 layers. We have multiple
Yes.
models now, but it started with AlexNet. So we can use that as a base point.
So just a general thing I want to ask,
Yeah.
like whatever you are teaching Gen AI and deep learning, so can we learn the same like from orally? Because I have orally hands-on machine learning, like PDF in online. So is that you are taking from that book or something?
No, I'm not taking from any book actually. I'm just making slides from the lecture content and I'm annotating on them. I'm not taking any book content for this.
No, because content. Because if I get to know the source of the content, I can easily read.
Sources myself only from different sources. There is no fixed source.
No, source of the lecture, I mean.
Source of the lecture that sir is taking. Are you talking about that?
Okay. No. Yeah. I'm source of the lecture. I'm just talking not about lecture.
So I don't know from where sir is taking what I'm doing is I'm looking at the lectures and I'm combining the topics
Yeah.
and then scraping the resources from different places and myself only. That is what I'm doing. So no book. I'm
That's
not
like
looking for any book.
there in supplementary content.
Okay.
What is there? A book is there.
There are 2 books given to us at like suggestive reading books in the portal itself.
Yeah. So you can use them, right? That is a good thing. I have not used them. Like for my lectures, I don't use them, but you can use them if they have suggested. Then yeah, deep learning with dive into deep learning is a very good book. Actually, I've also heard about this. I've not read this, but it's
Orally is very famous, like for the this.
Yeah. This is a good book, very good book. It's a very famous book. I have heard about this quite a lot. So you can go through I think all the topics have been covered in this. You can go through this. Yeah.
Okay.
These are actually suggested by the professors and the instructors only. So they have worked upon and found a lot of books, and they found that these are actually very good books. So they're pretty good. Yeah. Yeah, I think Venkatesh, I think we can go ahead now with your question. You can unmute.
I'll ask when everybody is done. I think everybody is done.
No, everybody whose hand was raised is done. So I think you can ask.
Okay, so assuming that there are just 14 days for the quiz 1, and assuming that I don't know anything about this course, what is the way to study? Because I find it very overwhelming, despite me having completed all the machine learning requirements, and
Right.
MLF, MLP, and MLT, and all this, and still there's no connection between basic machine learning and deep learning, because these two are entirely different things, although they sound very similar.
Right.
Where in deep learning, the machine itself decides which model to be used, and in machine learning, it's we who decide. Right? So how do we prepare for the quiz? Because all things said and done, I mean, we can discuss a lot, we can argue, debate, and complain, but that's not going to help anyone, right? So how do we prepare for the quiz, assuming that I don't know anything about this course?
Okay, so see again, coming back to the point that a few people raised also, this course has two major sections, right? Which is theory every week and the practical part of that through PyTorch, right? So the quiz that you will have will contain a combination of both. Okay, it's like the GS. You can have to look at the GS. You will have theory questions mostly, and you will have also code-based questions where you don't have to memorize much syntax for those questions. You can in the GA you can have syntax based because you can look the documentation, right? So that's why we give them. But in the quiz, whatever code-based questions are there will be more or less logical. It won't be learning-based. Like you have to know this particular function and then only you can solve it. So if your theory part is clear, like if you know how to calculate parameters of a CNN, which we covered towards the end of today's session, right? If you know these things, then you can score well. If you want a quick of course, I'll suggest the lectures, but in case you don't have time, then you can go through my 3 sessions so far for the 3 weeks and the 4th one, which is coming up next week for the theory. That is going to be sufficient for the quiz. So whatever is going to be asked in the quiz, if you go through these sessions for theory, but I'm not talking about the PyTorch part because I've not taught PyTorch yet. So whatever is there in the theory part, if you cover my live sessions, it is sufficient for the quiz point of view because I have covered all the topics that are required. Okay. Of course, I'll suggest watch the lectures for the completeness, but if you don't have time, since the time is less now, as you're saying, if you have not started very well, you can start with the live sessions.
See, the thing is, I just don't have any knowledge of this. Like
I don't assume any knowledge in the live session. You can start from my first session. There is no knowledge that has been assumed. I have started from the absolute scratch and I have started from machine learning. In fact, we started with linear regression and then we jumped into how regression leads us to neural networks. So no knowledge is assumed.
Because I started making some notes, but I find it, see, the lectures are very disjoint to each other. And I mean, introducing PyTorch without even explaining what is a tensor, that seems to be like, unacceptable for me. And it doesn't make any sense because I had to then go and see what is a tensor and, the mathematics behind tensors and all that. Because I am somebody who cannot, who doesn't feel satisfied if you just know a few things here and there just to pass the quiz. Okay? That's one way of doing the course, but somehow I don't find I don't think there's enough time for learning anything. Even the first chapter will take 14 days for me.
Right.
So given that, how do I think of getting a very good score in quiz? Because these days, see, in this particular course, the final exam has only 0.2 weightage, okay, and the quiz has 0.15 and another quiz has 0.15. So apparently, like I'm also in a situation where I have to improve my CGPA. So I cannot just think of passing the quiz because so far people have been saying you just think of passing, but I just want to ace the quiz. So what is the way out? Because I am just, I keep reading, and at the end I see that I don't understand anything.
So I would again suggest, due to the limitation of time, you just go through the live sessions in a sequence because the live sessions are connected. If somebody else can comment who has watched all the 3 sessions, can you comment on whether what I'm saying is
Because
correct?
the lectures are useless because it's so drab. It keeps going, like on and on for hours, and there's no rhyme or rhythm to anything, and no introduction. It just starts randomly in the PyTorch. I mean, people have been using PyTorch without knowing anything.
Mr. Venkatesh, what I would suggest is it's better to start with the theory. I think tensors we can learn progressively. I think we don't have to.
But without understanding what is tensor, you can't do much. I'm not somebody who. I'm not someone who learns.
Yeah, you are right. But the theoretical concept, let us go with that, and then let us break it.
I don't understand, right? The problem is, I watched all the lectures. It's not that I didn't do that, but then and I also.
Then you should watch the live session because these people's live sessions.
I'm attending live sessions. But I'm not able to get a grasp of it.
No, did you attend my live sessions in the last 2 weeks? Because I don't remember seeing you there. Did you attend them? Like, were you there?
In one of them where Anamika was there, I was there, and there was another one where I think Pulkit, right?
I think no, sir.
Yeah, so you
He's
attend
not
my
attending.
all are
sessions.
very very nice.
For the theory part, you attend my sessions in the sequence. I think that will help you.
Yes, sir. That was really helpful.
Yeah. So my sessions were
For
on
me,
every Saturday. You just watch the recordings of that from week 1, week 2, and today's one. I think that will help you out. What I feel it is, it should help you out. I'm not saying I'm done doing wonders and somebody's not. That's not what I'm saying. I'm saying because I covered the theory one like in sequence in all those sessions. That's why I'm saying that should give you a completeness. Then you can watch the other sessions also.
I find all suggestions here without knowing my situation. So anyway,
I
so
think
there's
I'm
nothing.
knowing your situation and telling like in any of the sessions that I've taken so far, so none of these sessions have assumed any knowledge from the student side. We have started from the absolute beginning. Like suppose today I assume that students know CNN, so I can straight away start with the CNN formula. But we started it from the image, like what an image is, how does an image look like. So we started from the scratch. So there is no knowledge of lectures and concepts that I've assumed. Like if you watch them, I think they should be helpful, in my opinion.
See,
Others who have attended.
if you watch, yeah, I understand. Thank you for that. But if you watch the lectures by Andrew Ng, Stanford CS 229 and all that, see, there's a
Yeah.
lot of maths being taught before they go into PyTorch. And I think that's kind of more.
Yeah, I have taken your feedback that we should first cover the theory, then the PyTorch and the lectures as well. That
Yeah,
I
and even at MIT OCW by Alexander Amini and his Ava Amini. So they all,
see.
of course, those kind of lectures are not like all encompassing. It's of course not very informative as well because they have lots of TAs and like similar to our system. But at least they have something where it says like what is a sigmoid function, what is a ReLU, what is a
Yeah.
max and all that. But we don't even have that. We just started with PyTorch. That doesn't make sense.
See, I have covered all these things what you're telling in detail in the previous two sessions. So that's why I'm telling you. Just give us my two sessions and this one a watch. I think most of your queries would get resolved. Give it a shot. In the next week when I come here on Saturday, you can tell me if it was helpful or not, right? And on the basis of that, we can.
I'm not feeling confident at all about the quiz part. So
That's why I'm telling you. You have time. I have taken 3 sessions. Watch the 3 sessions. You will be confident.
Venkatesh, I just shared my number. Monday we can discuss. We can
yeah,
do this. No worries.
See, just as a
Thank you.
fellow person in the team, take my reference. Just watch the 3 sessions of mine in sequence. That is week 1, then week 2, then week 3. I'm 100% sure you will be confident about the quiz, at least to some extent. Just give it a shot.
Sure,
Okay.
I'll do that. Yeah, thanks.
Yeah, my sessions are on all the Saturdays. So just go to the Saturday calendar and you will find the recording for all my first session, second session, and third session, which is today. If you watch the 3 in sequence, I'm 100% sure you will be confident about the quiz. Okay.
Okay, thanks. Yeah.
And also I would suggest don't panic. I mean, start from fresh. If you haven't understood anything, that's fine.
Yeah.
Watch such lecture because even I found lecture very kind of monotonous and difficult, those recorded lectures.
No, because see,
But,
I just see the job requirements, the JDs that keep coming to my email all the time, and then they ask for PhDs in deep learning and all that. And I know that the subject itself developed around 2020, and how many PhDs they'll get in India, I don't know. I mean, this is that's why I don't believe in this, industry matching syllabus. No, that doesn't make sense.
no, that's fine, but I feel because I'm working as well, right? So that's why I'm saying because at least I find the content here is comparable what you will see. So in the industry, so you can trust. At least first, don't panic and trust the process. Start watching the live lessons. Even if you haven't watched anything, you haven't understood, you can still cope up with it. So don't worry first of all, because under panic you will not understand anything. So
Yeah,
first you have
that
to calm down and
exactly what you say is happening because when you're panicking, you try to read that resource and then again come back to this resource and then
yes.
Googling and then go back to this book and download that book and finally you see that you have spent a lot of time without understanding anything.
Yeah, that
So
was
that's
happened with me when I watched first lecture. I was not able to understand, but science search lecture are really helping me. So and at least watch those, and if you don't understand, then I mean you because see other people are there to help you. Even instructors are there, so don't worry. Okay.
Oh, thank you very much. Thank you. Yeah.
Yeah, so I think that was good. So yeah, any other question? Anshuman, you have raised hand, right? So any question, Anshuman?
Yeah, could you please explain week 1 GA question number 12 for me?
GA we cannot discuss in this session because it is being streamed. So you can ask that in the TA session, right? They'll explain you in the TA session.
Its deadline is over.
No, it's recording. It is actually auto-recorded. It will record till the end of the meeting. Till I am in the
No,
meeting, it will record.
So you cannot even revise with us. It's not allowed for you for revision even.
We can do that, but we can't do it in this meeting because it is recorded. We can arrange another session for that and do that, which is not recorded. That we can do.
Even when deadline is passed, we can't ask.
Because the assignment might get repeated next term, right? So if it is streamed, the student can watch it next term and get the session.
Got it. All
So
right.
it is not allowed.
Actually,
But
I
it
asked
can be done. It can be done in another session, which is not recorded. That we can do.
Actually, I asked in the TA session, but I did not get a satisfactory answer.
Which question you want? And like, let me just have a look. I cannot give you the solution here, but I'll just have a look at it. Maybe help you with some approach.
Week 1, question number 12.
12. Okay. Let me just check. If you need a GA revision, we can have another special session in next week, and in that, or maybe next week, and we can discuss all the GAs. In that,
Sayan, I think all of us would agree that if you could bring questions from your side, like you gave us in the GA, the questions are very less actually. That's one of the problems why we are so struggling. If we had more questions to solve, probably we could have a better understanding of what we are learning. That is why we are asking so many questions, because this is from my point of view. Other courses, they have activity questions after every lecture, or they gave us more GAs to solve. I agree that we all have time issues, but if we have more questions to look at least this course will become more hands-on for us. We learn from your session, and then there is nothing to apply into because we don't have questions to solve. I think I have already given this feedback that if you could increase the number of questions, then we'll reinforce this learning. We are only looking forward to a Saturday session that, okay, we'll have a revision. But what after that? We are not revising anything.
Yeah, I think that is a good suggestion. So what we can do is we can have, apart from the GAs, we can have a 10 to 12 question bank every week that we can share it to you. And after that, we can also discuss them in our GA sessions, right? That can be good. We can
Excuse me, sir.
Yes, sir.
Yeah, sure.
Excuse me, sir.
Yes.
Sir, I completely agree with Mona Lisa. One session taking for problem solving right now, as well as question with coding some.
Yeah, we will do that. We'll do a solve with us session, right? A new solve with us session we can do every week. That we can do. Sure.
Yes, sir.
Both of these feedbacks are very good. I will make sure that the team gets it and we will work on this and get started from next week. That will be done.
Thank you, sir.
If
Yeah,
you could
sure.
just the question practice assignment, that will also help. Like practice.
We can solve the PA. PA we can solve anytime. Even in streaming, we can solve PA.
No, what I'm saying is for upcoming weeks, we could if we increase the amount of questions in practice assignments, then we can
How many do
discuss.
you want? Like how many are you getting right now?
So for example,
in one practice assignment, we have around 10 to 13 questions, and in a graded assignment, it is from 13 to 15 questions. That's all we have.
Okay, so I think 10 more questions, 10 to 12 more questions would be good.
If you could, yes, add one more practice assignment, 1.2, two assignments, two practice assignments and one graded. That will help us a lot.
Yes.
Yeah, that we can do. We can do that. Yes.
I have filled the feedback, but still I wanted to get it across to you. Since you all have planned this course as half theory and half coding per week, so give us coding assignment also. I know I'm increasing the workload. Everyone will hate me here, but this is the reality. We are just looking at the codes which the TA is telling us, but we are not practicing according to questions.
I agree.
To build a foundation into PyTorch also, give us Devi questions, but at least give us.
Yeah, I got it.
I am ready to take the hate here, but this is the reality. Deep learning, we want to learn it, and there's a lot of workload. I cannot even describe my workload because I'm bedridden right now. I have a right side fracture, but I want to learn it, and I'm still wanting more workload. This is the only way to learn.
No, I get your point.
Yes,
That is a good point. Again, we can have coding assignments where you actually write the code, run it, and get the output, right? That we can do. That is a good suggestion again. We'll do that. Sure.
Yeah,
and nobody will do any hatred because we'll make it a practice assignment. So
yes, sir.
It won't be great.
I will agree with.
Yeah,
let
we'll
me
do
ask
that.
a makeshift question. Since we can't discuss the GA. I hope this question will be clearing my doubts. So, question 12, statement 3, that is B is equal to toss dot rand n bracket 4. So, what would it create? A random four tensors, one dimension tensors, or
One second,
one tensor with four dimensions?
Just give me a second. Yeah. Question number 12, right?
Yeah, statement 3, B is equal to toss dot rand n bracket 4. So what would it create? Four tensors with one dimension or one tensor with four dimensions?
Torch dot, yeah, I've just reached the question. Torch dot, no, this is going to create one tensor with 4 dimensions.
All right.
Okay. Yeah, one tensor.
Okay, thank you.
See, all these codes which you get in the snippets, right, in your GAs and PAs, just open a collab and write them and execute them. That will give you a good idea.
We did that, but we need to understand the background also.
Yeah, that I got it. I'll give you we'll give you full end-to-end coding questions on PyTorch, which will help you. That we'll do. But I'm just saying that whatever you have the snippet questions, and that also, if possible, write it and check it out once as well. Right? That will be helpful as well. But we will give you coding, like full proper code, write code and solve type of questions. That we will arrange.
Venkatesh, you have not missed anything. The morning sessions are actually not there. By mistake, they have tagged the wrong calendar link. There are no morning sessions happening in our course.
Okay, because that's why I was wondering.
No, you are not missing out on anything. There are no morning sessions. There's a wrong thing circulating. Please check the discourse. Today I have replied to someone with the correct calendar link. You can find it from
Sessions
there.
are only evening. We only have 8 to 9. That is the session, right? Only evening sessions.
Okay.
Yeah.
Okay, thanks.
Yeah. Yeah, okay. So I have got a good list of suggestions from all of you, and I'll make sure that we communicate it to the team, and we will work upon it from next week. And as soon as possible, we will come up with more questions, the coding especially, where you can write PyTorch code and get some solutions so that you can get an idea of how that works. And also during the instructor or TA sessions, we'll try to keep some session or some slot for problem solving, right? Where we bring up more questions, not existing, more questions, right? So that we can solve them out, and you'll also get a good idea. Plus, you'll get more questions for practice. Right? So yeah, that will be done. So thank you for the suggestions, and please keep giving suggestions, because for the team also this is the first time for the course, right? So we'll need suggestions to improve it, and I'll make sure that we have a meeting on this and get it done well.
Excuse me, sir. I have one thing said.
Yes.
So in a class, first maintain discipline with all student as well as teacher. If any students misbehave with teacher or instructor and any use meaningless word, then you take action.
You're talking about me, right? I'm much more senior than all of you. Okay, so
Yes,
doesn't
you are
make
a senior,
sense.
but not you have a right to use
Who are you
right word.
to
Okay,
suggest
let's not
action?
get into this, but I think the point was clear. We'll have, like, everyone will have a peaceful.
See, this is nothing.
No, sir, I have also workload
Discussion.
for course 2 project as
I
well
didn't
as
even talk to
preparing
you, right?
thesis
See,
essay.
I don't even
I
talk to you.
know
You are
how to
suggesting.
manage this.
No, I didn't
Ronak,
talk to you or
please
ask.
drop that. Sir, Ronak, please drop that. Don't discuss.
Yeah, I mean, what is this? Take action on somebody. What is this? Are they trying to, I don't want to use that word, but what is this? I mean, it's up to the people who are in charge to take action or something. What is the thing that you found with me? What is that you don't like about what I spoke? Can you explain? Hello.
You watch them recording, you understand what you'll say.
No, I don't find anything. I am very conscious of whatever I spoke, and I wanted it to be that way. Okay. There's nothing wrong in whatever I've spoken. I mean, maybe some words are harsh, but
I
that's part of
am
life.
not saying to you, I am saying, sir, KITM mentioned already you discipline all instructor as well as
That's okay.
all
That's there
TA.
everywhere. I mean, see, we are just discussing,
And
right? What's the point?
IITM have also
What is out
every
of
course which got
discipline?
defined rule.
Yeah, what is out of discipline you found? What is not discipline that you? I mean, how do I call it? What is the breach of discipline did you find? Can you explain, please? Hello. Hello.
Yeah, okay. I think we have to
No,
end this.
because this is unfair, right? I mean, he cannot just say that you have to take decisions. I mean, you have to punish somebody and all that.